So what is Go? So Go is a programming language created by Google. With a simple grammar, it's easy to learn and well suited for team development. Another characteristic is its speed. It is also a language that is growing in popularity. So it's used by everyone from startups and where development speed is very important to large scale systems development. So what can Go do? Websites. So in the website, the backend part you can write in Go language. It is very good for scalable applications. And also JavaScript will still be there. But the Go, since it's very fast and it provides concurrency features, it's very much used in backend of the websites. Next one is mobile applications. It is used in mobile applications also for front-end part, then systems programming, many network servers, distributed computing systems in Google and YouTube are using Go language. So this is also used for server-side programming. So let's look at the history of Go. So it was originated as an experiment at Google by three people, mainly Robert Wismer, Rob Pike, and Ken Thompson. So the goal of Go language was to provide a development speed of Python with the performance and safety of C or C++. And it was created at Google in 2007. So now let's look at how to install it on your system. So here we are on the website of Go. You can see the website name golang.org. In here you can see it is given as Go is an open source programming language that makes it easy to build simple, reliable and efficient software. So you can click on download Go and it is available for all the major operating system. You can see Microsoft Windows. .msi installer is there. For Mac OS we have package and for Linux we have tar.zip. So I'm on Mac, so I will download for Apple Mac OS. Since I've already downloaded and installed it, I'll just show you to verify if the installation is proper or not. I'll just open my terminal. You can open your command prompt and inside that just type go, that is Go, and if you run you should get this message as Go is a tool for managing Go source code, then usage, Go and then command and all the commands. You should be able to see that, which means you are successfully installed the Go compiler on your system. Also if you are on Windows, you can go over to C drive, the file explorer, and under that you will have a folder called Go. Inside that there will be a folder called bin and you can see the two files Go and GoFMT. These are the two compilers which are required for Go programming language. So if you are successfully installed, these files will be there. So now let me show you how to write a simple program in Go programming language. So my choice of IDE is Visual Studio Code. I'll encourage you to download and install Visual Studio Code. So if you go on YouTube and search for programming knowledge VS Code installation, you will get the video. Just watch the video and install the VS Code on your system. Let me open the Visual Studio Code. So in here I'll close the welcome tab and in the Go, I'm in the Go folder. I have made the folder. So here click on that icon and just type the name of the file. So in my case I will type hello and the extension is .go and just press enter, and in here it will tell you that the Go extension is recommended for this type. Just click on install. It will say installing. If you click on that, it is saying installing and you can see 3 million users and it is around 4.5 star. It is by Microsoft, you can see, and it is already installed. Now I will close it and in here just close the warning. You start typing the code. So every Go program will have a main function. So type main open and close parenthesis, and then open the curly braces, open and close the curly braces, and type enter. So this is the typical main function. All the functions are defined by the keyword func func. So type func in front of main function. So our main function structure is ready. So inside this, if you want to print hello world, so how will you print it? So you will need one module for that. So the module name is fmt. So type fmt dot, you have to call a method from this module. So type capital P, then print ln. So this is same as Java's println, and open and close parenthesis. Inside this, open and close inverted commas, and type the message. In my case, I will type hello Gunesh. And as you can see, this fmt, we have to import it. So type import and open close inverted commas, and inside that we have to type fmt. One more thing is that the main function is present in the package main. So type package and main in the beginning of the program, so that the main function can be called from the package. So now our program is ready. One more thing I want to show you is, after the main function there is parenthesis, and if you try to bring this curly braces on the next line, it will give you an error, because the Go language syntax is like that. You need to have curly braces along with the main function. And if you go on top and if you select the run and the start debugging, it will give you an output. And in here, from the side, you can select terminal. Here you will get the terminal, and in here, if you type ls, in your case it will be dir, you will see the file name hello.go. Just type go space run and the name of the file, that is hello.go, and it will print your message. If you make some changes to the print message like welcome to programming knowledge, and if you run the program again, you can see the message as hello Gunesh, welcome to programming knowledge. So in your Visual Studio Code, what you can do is close this and just go on top, and in here you have to go in view and then command palette. For that, shortcut is shift command P or control shift P, and in here type go tools. So it will say go install and update tools. Click enter, then it will give you this list to checkbox. Just click on top and it will select 16 of these packages. So these are all for code linting, that is formatting your Go code, and then testing packages, etc. So it will take some time. Just let it install, and you can see the path it is giving. It is users Gunesh S /go /bin. One more thing I want to show you is, if you go on top and if you select that command palette, here you can type shell and it will show you shell command, install code command in path. Just click on enter. So what this will do, it will let you open the VS Code from your terminal itself by running the command code. So it is telling shell command code successfully installed. Let me open my terminal. It is item. So in item, if you type code, press enter, you can see it is open this Visual Studio Code. You can see it is telling these are the packages that are installed and 2 tools failed to install. That is okay. So now, so this is how you install the Go tools which are needed. How to install Go language in your Windows 10 machine. So let's get started. So I'll open my Explorer, Windows Explorer. So in the downloads folder, I have my Go installer, and I will just open the command prompt first to show you. if I type go, you can see it is not recognized as an external command. And now we'll double click on go installer, and it will ask for destination folder. We'll give C drive go default and click on next. So it will install. So it is installed, and click on finish button. And now if I go and type go in the command prompt, you can see it is giving us options and all the commands that are available with the go command line utility. So let's open the environment variables, search for env near Windows search bar, and open system properties and environment variables. Inside here you can see the go path in the user variables, and down you can see in the system variables we have path. If you double click on that path, in the end you can see we have C drive and the go directory, and inside that we have bin directory. So this is the place where the go is installed and all the packages and files are stored there. So let's open the C drive, and in here you can see in the go folder we have bin folder. Inside that we have two files, two applications, go and go fmt. So this is the main go compiler. Let me close this and I'll click OK. And in here you can see the go path. So this is where our projects will be stored. So we'll change this to our desktop. So we'll open our Explorer and we'll go to desktop, and in desktop we'll create one folder called go minus workspace. So this will be our folder where our projects and all the models will be stored, and we'll just click on go path and edit, and in here we'll go and select browse directory instead of giving the path directly. In the browse directory we'll select Punesh Shanbag, the username, in the desktop, then go workspace, select it and click OK. And now it is selected, and now click OK after confirmation, and you can see the go path is changed, and click OK. We'll close this. We'll open the command prompt. In here if you type go space env, let me clear it first. Clear doesn't work, so we have to type cls in Windows, and now type go space env. So it will show all the environment variables present in the go language. So right now you can see here we have go path, which is pointing to the go workspace on the desktop, and go root, which is pointing to the go folder in the C drive. So go root is the place where a go program is stored, whereas go path is the folder where our projects will be stored. So whenever you run a program, it will go to go root directory and it will execute. So now we'll open our folder in VS Code. So you need to install VS Code and select now the folder, it is go minus workspace. You can see here it is opened. Just click on that, and in the first icon, that is new file, click on that and give the name of file as hello.go. This will be the go file, and we'll just, and you can see in the bottom right corner the recommendation for installing the go extension. Just click on that and it will install. And we got another one, go outline, which is the go tool. So click on install all. So these are different tools and packages for go language. So it will give a list of that, and you can see installing 17 tools at the particular directory in the model mode. Since we have not given the tools go path, it is by default using the go directory in the users folder, as you can see. So let it install. In the meantime, we'll just type our program. So the comments are written by using 2// and then you can just give a comment. So this is go file, and the first line always should be after a non-comment the package name, that is package, and we have given workspace. Then click enter and then just type import then fmt, that is the module name which we want to import, then give the function name. In our case it is main, so func, that is func space main, and inside it we'll give fmt.println just to print hello world, or in this case hello Ganesh. We can see our all tools are successfully installed and we are ready to go. And in here, in the problems tab, you can see expected package found EOF. So we have not taken into consideration the main package. So we have to import main package to use the main function. So package main we have done. Just click on save. Now you can see problems are gone. And now we'll just close our extension tab and we'll just go in the command prompt, and in here we can type, first we have to change the directory to the desktop, so cd desktop, and then cd go minus workspace, oops, cd go minus workspace, and in here type go space run space hello.go. So this will compile and it will print the output, that is hello Gunesh. Now let me show you how to run this in the VS Code itself. So just click on debug and click on start debugging. So wait for some time and it will just print the message, that is hello Gunesh. So this is the output you can see in the debug console. Alternatively, you can also use F5 key to run the program. So this is how you install and set up the Go language in Windows 10. So in today's video, we'll be learning about the Golang variables. So my name is Gunesh Shanbhag and you're watching Programming Knowledge. So today's video will contain, the first thing is variable declarations. So how variable is declared in Golang. So I will discuss about that. Then we'll learn about the redeclaration and the shadowing principle. Then we'll learn about the visibility of variables and also the naming conventions which you should follow while naming your variables. And then we'll look at the type conversions in Golang variables. So let's get started. So let's open our Visual Studio Code, and we can see that in earlier code I have shown you this basic hello world, that is hello Gunesh, welcome to Programming Knowledge. We had printed using FMT library. You can see the output here, hello Gunesh, welcome to Programming Knowledge. So let me today show you about the variables. So we'll just remove this, and there are three ways of writing or using the variables in Golang. So the first way is you have to write where keyword and then the name of the variable which you want to use. So in my case I will take it as a, and then the type of the variable, so data type I will give it as int. So this is your declaration. In other languages like C, etc., what you do, you first write the type of the variable, that is integer, then the variable name and the semicolon. But in Go, we have to write the where keyword first, then the name of the variable, then the type of the variable. Okay, so after declaring in the first line, we'll just initialize it. So a equals to, let's say, 12. So we have initialized. So this is the first way. Okay, and let me print it. So what we can do, we can call fmt dot print ln. P should be capital, and you should use the Go extension. That will be very helpful for you. And let's just print a equals to, let's say, a. So fmt.println, in the double inverted we give a equals to, then comma, then the variable, and we can run it. If you want to run, you can just go in, run, and start debugging. F5 if you click, it will run, and you can see in the debug console you got a equals to 12. Okay, so now the second way is, let's take a variable b. So where b, then equals, will give integer equals to 12. So as compared to the first one, we had two steps here. First declaration, then the initialization. Declaration and then initialization. But whereas here we are doing the both in one line. So this helps you if you want to save your time, and we can print this. If you go here and B, and this will give error. It will say it is declared but not used. So anything you declare, you should use it. So right now we'll just comment it, we'll run it, and we can see B equals to 12. The third one, or the third way is, don't use where keyword, directly give the variable name. For example, C, then instead of writing equal to, write colon, then equal to, then give your value, that is 33 for my case. So now comment this and we'll type C equals to, let's print the value of C. We got C equals to 33. So these are the three ways of printing. So where these three ways will be helpful for you, let me show you. So if we have, let's put B and also A here, so the error goes. Okay. So if we have like, if you only want to declare a variable and you will initialize it afterwards in a for loop or somewhere else in a function, then you can use the first way. The second way is very helpful if you want to directly initialize it. So you can do this with this way. And the third way is helpful if you want, if you don't want to specify the type of the variable you are creating and you want the Golang to initialize it itself, then you can use the third way, that is colon equal to. So but in this what happens is, you are not giving anything, so Golang will just infer itself. For example, this is 33. If you make it as dot and if you try to print it, let me comment this, it will say C equal to 33. We got the value. We also want the type. So what we can do, we'll use a formatting string. So for that we'll use fmt dot printf statement. So inside this we'll give, in the inverted commas, double inverted commas, give percent, then capital T. So this will give you type, and comma percent v. So this will give you the value. So we want the value and the type of C. So give C comma C. And if you run this, you will get float 64 comma 33. Because we have added dot here, it is converting it into float. If you run it again by removing the 33 and a dot, you will get it as integer. So in Go, you have two types, float 32 and float 64. What if you want float 32? So for that, you will need to use the second way of specifying the type of the variable. So we can use float 32 here. And we can come here and you can put B here. So you can see it is float 32. But in whereas in the third option, we can't do it. So these are the three ways you can use variable declaration and initialization. One more thing is, the variable declared inside here, inside a function, are called as function level variable declaration. And if you are going to initialize them outside the function, then it is called as package level. So this is package level. And Remember this, whenever you are declaring or initializing variables in the package level, you can't use the colon equal to operator because it only detects the full declaration of variables in the package level. So if you want to use var int a, then you want to print it as 12, you have to give the full declaration. We will just remove this and we can get the value here and we can run it. And if you run this, we'll get an error saying undefined a. So let's look at it. So the syntax should be where a then int equals to 12. So keeping that in mind, so you don't mix up the syntax, and if you run it again, it will show you as int and 12. You can convert this into float 32 and run this and it will work. What if you add a string to the float declaration? Let's say hello. And if you run this, you'll execute it, but it will not run because it will say cannot use hello. That is a type of string as type float 32 for the assignment. So keep in mind it is strictly typed language and you give correct values. So this is done. Now let me show you. If you have a lot of variables such as for example, let's make this as id and we integer and the var, then name string equals to Ganesh, and then surname again string equals to Shanbhag. So what if you have a lot of variables in here and you don't want to use it again and again? So what we can do, we can include var like this, and inside this we can pass our all the values and we don't need to give var for each one, and this will work. Only thing is we have to give id name and yes name. We'll just convert this into a println. Let's run it and we'll see. So we got the error here because we have redeclared the id name and surname. So we'll just comment these 3 lines anything and we'll just type it. So we can see 12 Ganesh Hambag, it is printed. One more thing is some variables are connected with each other related to the id name and surname. You can just include them here also. For example, we have to keep count of all these. You can give count of I equals to 1. You can give like this, count of j equals to 1 and count of this is int. So you can keep track of count in here. So this is helpful if you have lot of keywords at package level. You can use var keyword to wrap them up in a single block. So now let's look at shadowing. So let me remove this and we'll just declare one variable on top here where a equals to int, and we'll just initialize it to 12, and inside here we'll just print it as a. And what we can do, we'll also initialize it the same variable a at function level and we'll initialize it to 21, and if you run it you can get the value as 21 and not 12. The 21 it came because in the local scope it is redeclared the value of 21, so that is printed here. If this was on top here, And if you run it again, we would have got 12 and then 21, because 12 is initialized to A at package level, and then it at the local level, local scope level, it is initialized again to 21. If you add here colon equal to variable, so A equal to colon equals to, let's say, 33, and if you run this, it will give an error saying no new variables on left side of colon equals to. Since we already initialized and declared the variable at local function level, we can't redeclare it in the same scope. So if you go ahead and remove the colon and just add the value to A as 33, the error will go. So keep in mind, you can't redeclare a variable at the same scope. The shadowing principle is that the value declared to a variable at local scope level takes precedence before the package level. So whatever we have initialized here as 21 is printed while we run this and not at the package level. So you can see we got 33 because it is initialized at the local level. So now let's look at the naming conventions and visibility in Go language. Let me just make it bigger and just remove this sentence. So we have one variable A declared here on top, and you can see it is in lowercase, which means that it is scoped to the package level, and that package is main, and outside the main package it can't be accessed. What if you want to access it outside the package main? So this is very helpful if you have a lot of packages. At that time you can do one thing, you can just make it capital letter so that it would be accessible to all the packages outside the main. One more thing is, if you have it at lower case, for example in here, so this is scoped to this particular block. So outside this block, this variable A can't be accessed. So there are three visibility in Go language. One is at package level, that is the same package with the small letter. For example, where A int equals to 33. So this is at the package level and at the same package level. And another one is at global level, so that it will be visible to all the packages. For that you have to have it as a capital letter. And third one is at the scope level. So scope level visibility will be visible, the variable's value will be visible inside the particular scope where it is declared and initialized. In our case, it is main function. So these are the three visibility criteria of Go language: variable declaration and initialization. Now let's look at the naming convention. So you have seen I have been using small variable names, for example, one letter. So these I have been using because these are easy for different things. For example, if you have I, so I can be used as a counter and you can use it for loop. So in Go language, the length of the variable shows the lifespan of the variable. So if you're using variables like I, j, k, etc., you'll be using for a short period of time for the for loops, etc. If you want to use it for long period of time, you have to give a clear naming convention for that. For example, if you want to use employee name, so what you can do, you can declare it as where then employee name, it will be string equals to Gunesh. So this is an employee name, and we have to give it as here. So this signifies that we will be using this throughout the main function and the packages. So for that we need to use a meaningful name. Keep in mind that you don't use very long names, just because your code will be read by other people also. So it might be difficult for them if the length of the character, like it is like 100 characters or 50 characters, so it will be very difficult for them to understand the variables. So keep it concise, keep it simple. So these are the naming convention. The other convention I will talk about is if you have some acronyms. For example, you have cookies or URLs as variable. For let's make it as the URL. So the normal tendency is we write it as at a camel case. So first the smaller letter and then the upper case for the first letter of the acronym, and we gave the URL link as https google.com, for example. So if we have acronyms, for example the URL, keep in mind that the URL is an acronym. So try to make it as capital whenever you see a URL so that it will be very easy to read it. So these are the two naming conventions which you should follow. One is for acronyms and another one for the length of the variables. Now let's look at the type conversions. So if we have a variable as int a equals to 12, and you can just print it as a. We'll use formatting string for that, and we'll type uh, the value of the variable, comma the type of the variables, that is percent %t, the capital T, and we'll give a comma a. Okay, so this will print our variable. Let me remove this statement from top. Okay, and what if you want to have one more variable, for example where int b equals to 12. I think we are missing the naming convention ourselves, so we have to make it as where a int and here where b int. So if you are coming from a Java or Python or any other languages, not Python, Java or C or C++, you have to understand this particular naming convention for the variables. We have where, then the name of the keyword, then the type of the keyword, and also we have to use fmt for this to print, and you should have p as capital, and for b we'll make it as float equals to, we'll just keep it as float. And if you want to convert this from the a from integer to float, what we can do is b equals to, we'll call the function float, and we'll pass a inside that, and we can just print it. Okay, so let's run it. You can see the 12 was integer, then we converted that 12 into float 32. So this is how you convert. You have to use the float 32 constructor to pass the variable which you want to convert it into. And if you want to convert this into a string, let me make this string. Okay, and if you run it, we are not getting anything here. The 12 is not displayed here exactly. So for this we have to use a package to convert the integer value to string value. That package I will show you. So that package is string conv. So if you come here on golang.org, and if you go in packages and search for strconv, you'll get this package. strcon implements conversion to and from string representation of basic data types. So just click on that and you will get the numeric conversion, how to do it. So you have to include the import strcon inside your import packages, and you have to use the strcon dot a to I that is ASCII to integer. If you want to convert string to integer, otherwise you can give I to A, that is integer to string. For our case, we'll give I to A. So let me open our Visual Studio Code and we'll just import. Inside here we will give import. We also want strconv, and in here we'll call strconv dot beyond I to A. It is integer to ASCII conversion. So we have passed A here. So let's run it. And you can see integer 12 is converted to 12 string. So this is how you do type conversions in Golang. Before starting today's session on primitives in Golang, let's summarize what we have learned in the earlier videos. Here you can see the summary. The first thing we have studied in the videos was variable declaration. So basically there are three types of variable declaration in Golang. So the first type is the declaration type, in which you only declare the variable name. The second type was declaring and initializing the variable. So we are initializing the variable with 42 and the variable name was ABC. And the third type was colon, using the colon equal to operator, that is a shorthand operator, in which we don't need to give the where keyword and the data type of the variable. The Golang compiler will automatically, implicitly will assign the variable data type. So we also discussed about use case of you having these three types of variable. So first one was only for having the variable declared and used it in a for loop or anything afterwards. So for that we use only declaration. Second was for using the variable there and there itself by initializing itself in the beginning only. And the third one was the shorthand operator, which saves time for us and we don't need to worry about the variable data types. But if you want to explicitly give data types, then you have to use second type of variable declaration and initialization. The second thing we had learned was we can't redeclare variables in a same scope, but we can do a shadowing in which you can redeclare the variables if you have them in a package level and you want to redeclare them in the local level, that you can do. But at the same level, that is in local level, if you want to redeclare a variable, it is not possible. It will give a compile time error. You can initialize the variable, that is reinitialization, that you can do n number of times, that is not a problem, but redeclaring doesn't work in Golang. And the third thing we learned was any variables we declare or initialize should be used. If they are not used, it will give an error, compile time error. That is because when our code becomes very huge and some variables we might not use afterwards in the old code, so that creates a garbage and we don't need the old variables to stay there for a longer time. So Golang does this implicitly. It gives a error so that we don't have spaghetti code in our code base. So that's a good thing of Golang. So any variables you declared, it should be used. The fourth thing we had learned about the visibility. So we had learned that if you have a variable declared in the package scope, if you give it as the first letter as lowercase, then it will be used in the same package. If you give it as in the main package, it will be used in the main package only. And if you want to export this variable to other packages, you have to make the first letter uppercase. So what it will do, it will export the variable so that it can be used in multiple packages. And there is no private scope in Golang, which means that you can only give the variable scope as if the block of code where it is declared. So if you have declared in the local level, it will be, the scope will be valid for that variable in that local level only. The fifth thing we had learned was naming conventions. So in naming conventions, we had two types. One was Pascal case and other one was Camel case. So in the Pascal case, what we do, we have the first letter as uppercase. And in Camel case, we have the second word, the first letter would be uppercase. And therefore third word and every word after that, the first letter would be uppercase. And the exception for that is the acronyms we use in the naming convention. For example, HTTP or cookies or URL. So those should be in uppercase. And next thing was the variable name itself. So try to keep them as short as possible. So if we have a variable counter, for example, I, so you will be using for I++ and all those things. So for that you can use I, J, K, etc. But if you have important variable name, for example, employee ID, which you want to use throughout the packages. So for those things you can use bigger names, that is longer names. So the longer names will have longer lives. So accordingly you have to name your variables. The sixth thing we learned was type conversions. So whenever you type convert integer to float, it will do it easily. But if you are going for float to integer, it will truncate the floating point values. So that doesn't happen in Golang. It will give an error. So if you want to do that, you have to use a particular function or data type. For example, if you want to convert integer to float 32, so you have to give float 32, and inside the parenthesis you have to give the variable which you want to convert. So that is the format. And if you want to use the string conversions, there is some package called strconv, it is string con, that you have to use for the string conversions. And there is no private scope in the type conversions. So now let's look at today's session subject. So it was primitives. So primitives in the sense the data types we have in our Golang. So the first primitive data type we have is Boolean type. So Boolean in the sense true or false. The next one is the numeric data type. So in this we have three types. One is integers, one is floating point, third one is the complex numbers. So these are the three basic types of numeric. Then we have text type. Text type includes all the strings, etc. So these are the three basic data types in the primitive section. There are many complex ones such as collection, etc., which we'll cover afterwards. So now let me open the VS Code and let me show how to use a Boolean data type. So we'll create one data type. So where n, then we'll give the data type that is bool, and we'll initialize it to false. And now we'll just print the value of it. So we'll use ffd.printf. So this is the formatting string printf, as we already have learned this. And we'll first print the value, then we'll print the data type, and we'll use the new line operator here, and then we just print the n. Okay, and now let's open the terminal, bring this down a bit. Okay, so now we can run, go run hello.go, and you can see it is printed the value as false and the data type is true, bool. So let me make it as true, and if we run it again, you can see the data type is bool and the value is true. So what is the use case of Boolean data type? So this is mainly used in two types, two categories, and the first one would be for having the state. For example, if you have a user system, your login system, and you want to show the user if he wants to subscribe for the newsletter. So if he ticks the box, you can have the value as true, and it doesn't, then you can have the value as false. So it will save the state of the particular item. So for that the Boolean data type can be used. The other one would be using logical test in your code. Let me give an example for logical test. So if you have variables such as variant bool and We'll use shorthand operator for this. It will be easier for us. So if we have n colon equals to 1 and we are just trying to equal it to 1, so this double equal to operator is called equals to operator. So it will check if the left hand operand is equal to right hand operand, and we'll have one more variable m colon equal to 1 equals to 2. So obviously this will be false, whereas this will be true. Let's just print it out, the output. We'll make this as m. Let's open the terminal. Let's clear this and let's run the command again. So here you can see n, for n the 1 equal to 1 is true, whereas for 1 equals to 2 for m is false. So this is how you do logical testing. So this is very helpful for that. And one more thing is, if we have a variable such as n and you have not initialized it and you have just declared it, then in other languages what happens is this value will have a memory reference or it will not have a memory reference. But in Golang it will have a memory reference and it will have a value as false by default. So by default it will have 0. So 0 in boolean means false. So if you run this and if you print this, it will print false, because by default any variable declared will have, any variable of boolean type declared would have 0 in that. So 0 means false in boolean, so it is printing false here. So in today's video we'll look at the integer types. So in integer we are already worked with it. So let's create a variable. uh, let's use shorten operator n colon equal to, let's say 22, and if you save this and if you run this, you'll get 22 and its type is integer, int. So there are many integer types. Let me open the slides. So there are different integer types. So these depend on the architecture where you run the code. So accordingly you have to choose the integer type you want. So it starts from 8-bit integers, so it is called int 8, then 16-bit, that is int 16, then 32-bit, that is int 32, then int 64. So int 8 will have a size range of minus 128 to plus 127, whereas 16-bit integer will have minus 32,768 to plus 32,767. 32-bit will have minus 2 billion to plus 2 billion, and 64-bit integer will have minus 9 quintillion to plus 9 quintillion. So how you can use the int 8, int 16? So for that you have to use second type of initialization method. So we have to use var keyword, where n, then you have to give int. So you can see in the options we got, the suggestion we got int 16, 32, 64, 8. So you can select 8, and it is also giving us all signed 8-bit integers range minus 128 through 127. So we can give as 127, 126, and we can run and we can get the output as 126 and its type of int 8. So this is how you use the different integer types. So depending on your needs you can use the about types. So if there is there is also a big package in math library, so it will help you for having very big numbers in your code. There is one more type of integer, it is called as unsigned integer. So those are basically of three types. The first one is unsigned int of 8-bit. So you int 8, its range is 0 to 255. Second one is 16-bit unsigned int. So it is ranging from 0 to 65,535. The third one is 32-bit unsigned integer. So its range is 0 to 4 billion. So how you can use it? We have to use where keyword, then n, that is the variable name, then you int which one you want to use, 16, 32, 64 bit and 8 bit is available. Then you can assign the value. And now if you save and if you run it, you will get 22 unsigned integer 8. So this is how you work with the unsigned integers. So if you want to use arithmetic operations, so what you can do, let's try that out. Let's have a variable called a which is equal to 10 and b which is equal to 3, and we'll just print out all of them. So here we'll make it as a plus b. Same we will use for a minus b for subtraction, a into b to a star b for multiplication, a divided by b for division, then a percent b, that is for getting the remainder. So if we now run this, so we don't have this one, so we can remove percent t, and if you run it again, we'll get a plus b, that is 13, a minus b, that is 7, a multiplied by b 30, a divided by b we got 3. So here you can notice that we are getting the only the integer part of the quotient from the division. We are not getting the exact decimal part because we are doing integer division. If you are doing something like 10.0 and 3.0, then it would have given us a decimal part of the quotient, and the remainder, as you can see, it is 1, it is displayed. So this is how we can use arithmetic operations. The second one example is, if you want to use, let's say, where a and it is type of int equals to 10, and suppose where b you have with int 8 equals to 3. If you are just doing a plus b, and if you run it here, you get invalid operation, a plus b mismatch type int and int 8. So in Golang you have to use same integer type for any type of operations. If it is not same type, it will show an compile time error. So let's convert this b into int type. So we can use int, and we can use int function, and inside that we'll use pass b. And now if you run this, you can see we got the output as 13. So we have to do these type conversions because the Golang doesn't do the implicit type conversion, so we have to do it explicitly. So the next thing is we'll look at bit operators. So bit operators, we have 4 types. First one is AND, then we have OR, then we have exclusive OR, then we have AND NOT. So we have an example here. So let's remove this, and we'll make it a shorthand operator, and we'll remove this one also. Okay, and we'll just print out the output of each and every one. So let's make this A and B, copy this, and we'll make this as and or B. Then third one is an exclusive or, so for that we have to use cap symbol. Then the last one is and not, so we have to use ampersand and then the cap symbol. And if you run this, you got output as 2, 11, 9, and 8. So let me explain. So in bitwise operator, what it is done is the numbers are converted into the binary representation. So binary representation of 10 is 1010, and the binary representation of 3 is 0011. So if you are doing A and B, what happens is it checks for the bit set where both of them are ones. So first one is not, so it will be 0. Second one will be also 0. Third one will be yes, so it will be 1. Then the fourth one would be 0. So this is the output we got, and this in decimal format is 2. Same way, the A or B, in which we check if either one bit set of them is 1, then we output it as 1. So 1 0, yes, 1. Then for 0 we'll give 0. Then 1 1, yes. 0 1, either 1 is present, so 1. So this, if you convert into decimal, we get 11. Same way, A exclusive OR. So in this, what happens is either one has the bit set or the other does, but not both. So both of them will not have the bit set. So here you can see either one has bit set. So you can see first one has a bit set. So it should be 1 because the first one has the bit set. Then second one, neither of them has the bit set. So it's 0. And either of them, that is both of them has the bit set in third one. So it's 1. And in the fourth one, either one of them has bit set. So it's 1. This should be 1001. And this, if you convert into decimal, we get 9. The same way for and not, that is opposite of or, in which it is true only if neither of the number has bit set. So in this we can see that it's 0, then 1, then 0 0. So these are the bitwise operators. Now we'll look at the bit shifting. So in bit shifting, what happens is we can shift a bit to left or right by a particular number. So we'll use one variable, that is a, and we'll use the value as 8. And what we'll do is in the bottom we'll bit shift it to left. So you use double opening angular brackets, and we have to give by how many steps you want to bit shift it. So we'll use 3, and then we'll do right shift, and for that we'll use again 3. So what happens here is, let me clear the command line. So 8 is actually 2 power 3. So if you are doing a bit shift to the left, it's 2 power 3 multiplied by 2 power number of steps you want to bit shift it. So we have to bit shift by 3, so we'll give 3. So which is equal to 2 power 3 into 2 power 3 is 2 power 6, that is 64. And the same way here also, if you are doing right shift, so what happens is 2 power 3, then divide by 2 power, by how many steps you want to bit shift it. So we have to do with 3 steps. So we'll give it as 3 here. So that is equal to 2 raised to 0. So that is actually 1. So let's run it and see if it is correct or not. We'll remove this 0, and if you run it again, they have to save this in particular variable. So we'll make it equal to, and a equals to. So if we run it again, we'll get the output as 64 and then 8 because the value is changed here. So we have to make it as, let's just comment this, and if we run it again, we get 1, so that is correct. So this is how you bit shift in Golang. Now let's look at the floating point. So in Golang, if you want to use decimal points, there is no way you can do that in integer types. You have to use floating point. So there are two types of floating point numbers. One is float 32 and another one is float 64. So float 32 ranges from plus or minus 1.18 into 10 raised to minus 38 to plus or minus 3.4 into 10 raised to 38, whereas float 64 will vary from plus or minus 2.23 into 10 raised to minus 308 to plus or minus 1.8 into 10 raised to plus 308. So these are the ranges for the float 32 and float 64 values. Let's start by opening the VS Code and let's clear this. So I will create one variable. So we'll use initializer type, that is our shorthand operator, n colon equals to, let's give 3.14. So this is the basic type of floating point number, and you can just go ahead and print it. You can use fmt.printf. Another way of writing the floating point number is n colon equal to, if you want to have like a big number such as 12.3 into 10 raised to 75. So what you can do, you can write 12.3, then small e, then 10 raised to 75 you can write as 75 here. So 12.3 and e75 means 10.3 into 10 raised to 75. Another approach you can do is, you can write a capital E instead of small e, and that will also work. So if you go ahead and print it, let's open our command line and let's run it. You can see we got command line arguments. We should not use no new variable, so we can't redeclare the variable. We can initialize them, so we have to make this as equal to, and if you run, you can see 1.23 into e plus 75. One more thing I want to show you here is, if you close the command line and let's make this into a normal variable such as var n, then if you give float 32 equals to 3.14, then 12.3 into e raised to 75, then 1.23 raised to e into e raised to 75. So if you run this one, you will get an error saying 1.23 into e raised to 76 overflows float 32. This is because the range of this, told you earlier, the float 32 will have a range plus or minus 10 raised to minus 38 to plus or minus 10 raised to 8. So clearly this goes beyond 10 raised to 8, so it overflows. So what you can do, we can use 64 here, and if you run this now, you can see the value is printed and we got the correct value. Because float 64 can go from plus or minus e raised to minus 308 to plus or minus e raised to 308. One more thing is, if you use directly this one, that is shorthand operator for initializing the variable, it by default uses float 64, so that's why we didn't get error in our earlier try. And let's make this a, and this will make it as b. So now let's try with the arithmetic operations. Let's remove this and this will keep it as 12.3 as A and 10.5 for B. And we'll convert this println to printf. We can directly give A plus B. We need println and we'll give A plus B here, and we'll copy this, and same way we'll do for A minus B, then A into B, then A divided by B. So let's run this. So we got our values. So you can see it is getting added, divided, subtracted, and multiplied. One more thing is we don't have remainder operator. Remainder operator will only work with integer values. It will not work with other values. One more thing is there are no bitwise operators for floating point, and there are no bit shift operators for floating point numbers. Those only work with the integer values. So now let's look at next primitive type, that is complex type. So complex types are very rare in programming languages. The appearance of that in Golang resembles it to be a very powerful language, and it can be used to leverage data science, etc. The complex number actually contains of two parts. First part is the real number and the second part is the imaginary number. And let me create one variable. So we'll have var n, then we'll have complex 64. So there are two types of complex data types in Golang. The first one is complex 64. The second one is complex 128. So 64 will take, and which will equate to 1 plus 2i. So here 1 is the real part and 2i is the imaginary part. And I is a special character in Golang, and it will automatically pass by the Go compiler as imaginary part of a complex number. One more thing is complex 64 contains two parts such as real and imaginary. So each part is 32 bit. So both of them combined will make it as 64 bit. So that's why it's complex 64. Let's print this out, fmt.printf, and we'll use our age old percent v comma percent t slash n, and we'll give n comma n. And if you run this, so you can see 1 plus 2i complex 64. One more thing, if you remove this real part, the complex number will still work. So you can see it takes 0 as the real part and 2i as the imaginary part. And let's try with arithmetic operations. We'll make this a println, and we'll a plus b, and the complex number will have one more. So we'll keep it as a and b, and both of them as complex 64. And first one will be 1 plus 2i. The second will keep it as 3 plus 4i. Okay, and let's print for all the values. And if we run this, we can see we got the values for complex addition, subtraction, multiplication, and division. And we don't have remainder operator in complex type. One more thing is, if you want to extract real and imaginary part from a complex number, for that we have built-in functions in Golang called real and imaginary. So let's try that out. So we'll remove this print part, and let's keep one value. And what we can do is, actually we can use print ln. So we'll convert this, and we'll remove this. We'll make this as print f and percent v comma percent t slash n comma, let's keep only a. So if you want to have only real part, same way if you want to have only imaginary part, we can have it also. For that image function is there, and for this also image function is there. So if we run this, so it will print 1 as the real part and 2 is the imaginary part, and you can see the real part is float 32 and imaginary part is also float 32. So both of them combined makes it as complex 64. So one more thing is, if you want to create a complex number and you don't want to give this in this way, what you can do, you can call complex function. So this is a built-in function. As you can see, it is given here. Inside this complex function, you can pass the values for real and imaginary. So if you want to create complex number of 4 as real part and imaginary part as 12, you can give it like this, and we can just print it here. And if we run it again, we can see 4 plus 12i complex 64 is created. So that's all about the complex numbers. So in today's video, we'll look at the last primitive type, that is text type. So in text type, we have two categories. The first one is string and the second one is a rune. So let's look at the string first. So strings are actually UTF-8 characters. So we have our floating point numbers here. So we'll just remove them. What we can do, let's create one variable of string type. So yes, colon equals to, we'll give one string. So let's keep it as hello world, and then just we'll print it. It's %v comma %t, then /n, and we'll give yes comma yes. And now let's run this. It will print hello world, that is the variable s content, and it will show the type of the variable, that is string. So suppose if you want to print a particular character of this string, you can do that. So the strings can be used as a type of array, and in array what we can do, we get a particular index and we can find the value at that particular index. So in arrays, the index starts from 0 and it goes till n minus 1. There is number of characters minus 1. So if you want to print the first L, so what we can do, we'll give index here. So for giving index, you have to open square brackets, and inside that the first L is at position 0, 1, 2. So it's a second position. So if you now run this, it will show 108. Instead of showing L, it has shown 108 and type of string. So what has happened here is, it is printing the ASCII value of that particular character. So if you want to print the string, so what we can do, we can wrap around a string function so that it will be converted and print the correct value of that string character. So let's run. So it is now printing L and its type of string. One more thing is, if you want to give here s of 2, and if you run it, so we have to remove this. If we run, you can see the s of 2 is type of unsigned integer of 8-bit, so that is 1 byte. Now let's look at, so strings are mostly immutable, that is the value of the strings can't be changed afterwards. So if you want to give s of 2 and we have to give here, suppose M, instead of L we want to give M. And if you try to do that, let's clear the command line. Let's run it again. It should say cannot assign S2. That is because the strings are immutable and you can't add any value to a particular string once it is assigned. So the only thing we can do here, that is arithmetic operations, is string concatenation, where we can combine two strings to form a new string. So let's make this as S1 and let's initialize it as good morning. And if we do here S plus S1 and let's just only print the value, it will say hello world, good morning. So it has added both of the values, that is it has concatenated the both of the string values in one single one. You can also do S2 colon equal to S plus S1. This is also valid and you can just give here S3 and if you run it should be S2. If you run it will say hello world, good morning. So this is string concatenation, and if you want to convert string to a collection of bytes, so in Golang it is known as slice of bytes. So if we have, let's clear this hello world in a variable s, you can convert this into a slice of byte. So you can use b colon equals to then two square brackets and then type bytes, and inside that you have to give the variable in which the string is present. So in our case it's s, and if you go ahead and print d, and we have to also add percent t, and if you run this, so it should be byte I guess. So we can see that we got an array of ASCII values, or you can say bytes. So this array of bytes is also called a slice of bytes, and its type is unsigned integer 8. So 8 means 8 bit, that is 1 byte, and this open and close square bracket indicates just it's an array. So in the form of array of ASCII values, or you can also call these as UTF characters. This is useful because a lot of functions in Golang actually work with the byte slices. So it makes our work very easy. For example, if you want to send a response to the client browser as a string, so you can easily convert the string into byte slices. Also you can use files. So files are also collection of bytes. So you can also use them in the similar fashion without worrying about the line endings and all those things. So you will be working with strings in your Go programs, but when you send it to other programs, you will be using byte slices for that. So now let's look at a second category of text type. So it's rune. So rune is actually comprised of UTF-32 characters. So you don't need to have all the way 32 bit in the runes UTF-32. You can have 8 bits long character also, and it can be a valid UTF-32 characters. So there goes a lot of work in the encoding of the characters to know whether the character is 1, 2, 3 or 4 bytes long. So this might make a bit tricky to work with rune. Let me show an example. So let's create a variable r colon equals to, let's give Yeah. So remember, when we are working with string, we used to give double inverted commas, whereas when we are working with rune, we'll give single inverted comma. So if you go ahead and print R, you can see it is printing the ASCII value, that is 109, and the type of the variable is int32. So that means it is 32-bit integer. It's because runes are type aliases for integer 32, where strings can be converted back and forth in between collection of bytes. So runes are actually the two type aliases. So runes in Go and integer 32 are one and the same thing. So that you have to keep in mind. Another way we can create rune is where we can give the name of the variable and then the rune. So you can say rune is an alias for integer 32 and it is equivalent to integer 32 in all ways. It is used by convention to distinguish character values from integer values. And if you run it again, it will show 109, comma, integer 32. If you want more information about the integer 32, that is rune, you can go ahead on the Go website. So in here, if you go in packages and if you go in strings and in the strings, the type reader, inside that you will have read rune function. If you open that, you can see here it will read a byte stream and it will fetch the next rune that is available and its size and error if any. So it is passing three things. One is the rune, next rune in the data stream, then the size of that rune and the error if any error occurs there. Another function is read bytes. So in the read byte you can see only we are getting a single character as a byte and a potential error. And this will help you in re-encoding the integer 32 to UTF-32 characters if you are using the read rune function. So if you are working with a data stream encoded in UTF-32, then you can make use of these functions. In today's video, we'll be looking at the constants which are present in Golang. So first we'll look at the naming convention which should be used for defining a constant. Then we'll look at the typed constants and then we look at untyped constants. Then we have enumerated constants and in the end we have enumeration expressions. So let's get started. So if you want to create a constant, we'll be using a keyword called const. So type const, that is const. Then you have to give the name of your constant. So if you have seen in other languages like C or C++, we use the variable in the form of capital letters, all caps. So for example, first, then underscore, constant. You print like this in other languages. But in Golang, we don't need to give like that. We can write first, that is first. So first F would be capital, first letter. Then in the camel case we can write that, and then we can write constant with C capital. One more thing you have to remember that in the variables I had shown you, if we have first letter as capital of a variable, then it will be exported to other programs. So if you don't want to export it, just keep it at lowercase, the first letter, so that it will not be exported and its scope would be at local level. And then we have to give the type of the variable. So in my case it will be integer. So int equals to the value I will give 12. So let me print here first constant, and let's open up our terminal and run our command, and you will see the value is printed, that is 12, and the type of the value is integer. So the next thing will be, let's see the characteristics of constant in Golang. So if you reassign the value of a constant, then it will throw an error because it is not permitted. So let me show you. First constant equals to, let's make it 13, and if you run this, it will say command line arguments error, cannot assign to first constant. That is because the constant means the value will not be changed, it will be constant. So once assigned, you cannot reassign it. So that's the first characteristic. The next characteristic would be constant should be assigned with the value at compile time. For example, if we have a function such as sine, cos or tan, or if you are calculating the pi value, so let me include math package in the import, and then if you go down here and let me remove this one, and let's type let's make this as float 64, and instead of 12 what we can do, we'll call our math package and we'll just use 10 function, and inside this we can give the value. I'll give it 3.2, and if you go ahead and print this, it will give you an error because this error is different. So let's just solve this. It should be capital, I hope. Let's run this, and we got an error. Const initializer math.10.3 is not constant. In here what happens is, while initializing the value for the constant, in the compile time we can't calculate this math.10 function. So this will be calculated at runtime. That's why it is giving error. So if you want to give a constant value, it should be at compile time only. So you can't use this type of functions which are needed to be run at runtime. So it's not a good practice and it will give you error for sure. So that's the second characteristic, that constant should be assigned with a value at compile time. So like 12 is a perfect choice instead of using some other functions. But one more thing is that we can make use of primitive types such as integer, string, float32 and boolean with the constant. For example, let's make it a, and if we have const int as 12 and then float as 3.14, that is pi value, as b, and then if we have constant c as string and it has a value as Gunesh, and if you have const d and that is a boolean value, if we have true, and if you go ahead and print this, those will work. Let me show you. Let's make this as C and let's make this D, and if you go ahead, clear the screen and run it again, we need to remove math because it's not used, and whatever is not used we should remove that. And we got the values 12, 3.14, Gunesh and true. So these primitive types work very well with the constant. And remember that there are some things like arrays which I showed in an earlier video, like byte slices, etc. Those things we can't use with constant because arrays should be always be used as a variable type. And the next thing is, in the variables I have shown you the shadowing principle. So that shadowing principle also works very well with the constant. So let me show you. So at the package level, I will create one constant a with integer value as 13, and at this is as package level, so I will put a comment package level so that you will understand. And this is at local scope. Yeah, and if you go ahead and print, you can see it has printed 12, so that is at local level. So whatever was there at package level, it's shadowed by the local scope. So local scope has higher priority. So if you make this as, if you comment this, let's see what happens. If you run, you will get the package level as higher priority. So what we can do, if you change the value of this as integer 16, int 16, and we'll use %t also here, comma a, and if you go ahead and run this, instead of doing this, what we can do, we'll make this as a plus b, and this will be b. So we will add int and int 16, so a plus b. Let's see what happens. Yeah, we got an error, invalid operation a plus b, mismatched types int and int 16. So in the variables I had shown you that we can't add two values of different types, so the type should be same for the values to be variables if you want to add that. So this you have to keep in mind. One more thing is that the shadowing principle you should not use in practice, because you might run into issues of different types of constants. For example, this one integer and int 16. One more thing is constant and normal variables can be added. So if you have this as constant, so let me copy, cut this, and we'll paste it here. And if you have a normal variable as b and a constant variable as a, and if you add both of them, those can be added. So let's run this, and we are getting missing something. Let's check. Yeah, so it should be a plus b comma a plus b. Sorry for that, and let's run it again, and we got 25 and integer. So the addition of two constant and variable types can be done, and if you change the variable type from int to int 16, that will not work. We'll get the mismatched error. We'll look at the implicit conversion while working with constants. So in the last video I had shown you the type mismatch while adding two constants. So one was having integer type, another one was having integer 16. So what if you have constant a without any integer declaration? So you are giving only const a equal to 13, and let's see what happens if you print that. Let me clear this, and let's, okay, you can see it is printed 13, which is the value of constant a, and its type is integer. So compiler implicitly found out that it is a type of integer. So what we'll do now, we'll have one more variable, that is b, and that will keep it as 16, integer 16. And now if you go ahead and add this with a plus b, and if you run the command again, it will print the addition, that is 25, and the type you can see it is of integer 16. So here you can see it was int a, and it was here integer 16. So there should be a type mismatch, right? So what compiler has done is it has replaced every instance of a with a constant value. So in our case it is 13. So what compiler has done is that it has replaced every instance of a with the value 13. So the literal 13 is added with integer 16 value of 12, in which 13 is implicitly converted to integer 16, and that's why the type mismatch error doesn't occur. So this implicitly conversion happens only with the constants and not with the variable types. That's you have to keep in mind. Let's have an untyped constant a at package level, and we'll equate it to a special symbol called iota. So let's have a constant a which is equal to iota. So iota is pre-declared identifier representing the untyped integer ordinal number of current constant. So I will show you what it is. And what we'll do, we'll just remove all this and we'll just print the a, and let's run the command, and you can see a's value is 0. So what is this iota symbol mean? Iota is a counter that we can use when we are creating enumerated constant. So this will work great when you have a lot of constant. So let me put this in a constant block. So what we'll do, we'll make constant block, we'll close this, yeah, and we'll have a equal to iota, then we'll have b equals to iota and c equals to iota. And now if you go ahead and print the value of each and every constant from the constant block, let's make this as c comma c, and let's run this, and you can see we got 0, 1 and 2. So iota works like a counter. So in here you can see that the iota is incrementing the value of the constant as each of them are interpreted. So a has a value of 0, b has a value of 1 and c has a value of 2. One more trick in here you can use is that you can remove iota from other two constant declaration. So if you remove iota from this two constant declaration, the compiler looking at the first iota declaration will follow the same pattern for other constant in the same block. So let's just run it again, and you can see we got the same value 0, 1, 2. So if you are on the same block, you can give iota to first declaration of the constant, then the pattern will follow for other constant also. So this iota pattern matching is valid for only the constant block where it is used. Let me show you. If you create another constant block with iota declared, suppose we'll create one more constant block, and in here I'll have one more variable m equal to iota, and if you go ahead and print this m, let's clear this and let's run it again. We can see 0, 1, 2 and then again we have 0. So this 0 is the value of m. So while printing the output, you can see that the counter is reset to 0 when the iota reaches the next constant block and finds new iota declaration. So iota is scoped to constant block. This you have to remember. An example of an use case like this would be if you have a college project to build and college has lot of departments and you have to generate ID of each head of the department. Then what you can do is, let's have three departments. Suppose MBA HOD. HOD means head of the department. Then we have computer science engineering HOD, and then we have information science department HOD. So we have three variables here, and the first one MBA HOD we have given iota, that means it will have value as 0. And in here what we can do is we'll remove the rest of the print blocks, and we'll create a variable, and it will have the variable name would be HOD type. So this will contain the HOD type, and it will be of type integer, and we'll equate it to the first HOD, it is MBA HOD, and we'll print in here, we'll check if HOD type equals to MBA HOD. And if you go ahead and run this, it has printed value as true, which means that MBA HOD was having 0 because it is the initial value of the constant block of iota. So we are equating it with, we are assigning the 0 value to HOD type, and when we are comparing it in the print block, we can see that it is true and the same output is printed. So this is one of the most common use case of enumerated constants. If we have CSE HOD, if we equate it to this one, and if you print it here while comparing, and if you run this, it will print true. But if you don't have this, and if you remove this assignment, and if you compare HOD type with CSE HOD, it will print false. That is because the default in the variable section I had shown you that if you don't initialize the value, by default it contains, the variable contains 0. So in here it is comparing 0 with 1 because CSE HOD is in place of 1. That's why it is printing false, obviously. And now the initial value of iota is 0, and if you replace CSE HOD with MBA HOD in print statement, it will print true. Let's run this. You can see it is printing true. Even though we haven't specified HOD type, it still shows us the value as MBA HOD. So how to rectify this? We can keep the initial constant value as temporary value. We'll remove this constant block, and in here we'll add one more HOD, that is temporary HOD, and we'll equate it to iota. So this will have value as initial value, that is 0, and subsequently it will have 1, 2, 3 for MBA, CSE, and IC department HODs. And if you go ahead and compare this with MBA HOD, the HOD type, let's run and show you, it will print false because the MBA HOD now contains value as 1 and HOD type contains value as 0. So 0 is not equal to 1, that's why it is printing false. In today's video, I'll show you another approach in which we'll be using a special variable called as write only variable, which is denoted by underscore. So in iota, no matter what the compiler will generate 0 value as initial value, whereas write only variable tells the compiler that even if you generate a 0 value, we don't need it. So the memory is not allocated to the write only variable and the 0 value is thrown out. So let me show you. So we will remove the temporary HOD, and in place of that we can write underscore. So this underscore is write only variable, and whatever the value is created will be thrown out. So now if you run, and it will print false. Let's run it. You can see it is printed false. So there is no change in that because HOD type contains value 0 and currently MBA HOD is now containing 1. So that's why it is printing false. The write only variable is used a lot in Golang programs. In this case, the 0 value is not available for this constant block. So this is the example of enumerated constants. Using iota, these constants are assigned at compile time. Some other things or operations which you can do with iota are addition. For example, if you have this constant block and if you want to add iota plus 3, and then if you go ahead and print the value of MBA HOD, let's say we don't need this, you can remove this. And if you go ahead and run this, let me clear this first, and you can see our output is printed as 4. So in here what happens is 3 is added to the iota, which is 0, and then in the next iteration the MBA HOD is added with 1. So 3 plus 1, it makes 4. So this is valuable if you want to have a fixed offset in your program. In the same way, we can use all the arithmetic operations, bitwise operations and bit shifting operations on these constants. So let me show you a very good example of bit shifting operation in Golang. In the earlier video for the primitives, I had shown you bit shifting, how it is done. So bit shifting is useful in areas where suppose you need to raise powers, but to do that you need a function from math package. And that function can't be run at compile time for the constant block. So this constant block should be run at compile time and not run time. So that's why we can't use the math package function. So in place of that function, we can use bit shifting to raise powers to 2. Since every time we bit shift a number one level, we are actually multiplying it by 2. So let me type out. And in here we'll have, let's suppose KB equals to, we'll have 1, then bit shift operator, and then 10 into iota. Same way we'll have MB. So all these are kilobytes, megabytes, gigabytes, terabytes, petabytes, exabytes, zettabyte and etabyte. These are all the file measuring units. And now what we'll do in the function main, we'll have a variable called file size. So I'm using camel case here. Then short variable initializer we'll use, colon equal to, we'll have a value, arbitrary value, we'll have this big value, and while printing what we can do, we'll have this value as a float value. That's why I'm putting dot here, and in here I'll use dot 2 to signify we want 2 decimal places, and F for floating point, and then we'll have capital GB to denote our gigabytes, and in here we'll have file size divided by GB. So this is the expression we'll be calculating, and we'll put it here in %2f. So let me explain what it is. So in here you can have a constant block with iota assigned to the first blank identifier. Next we have file size units from kilobyte to etabyte. Kilobyte is assigned by 1, which is bit shifted by 10 times iota. First time it is bit shifted 10 times 1 because iota is 0 here and then 1 here, which means that we are going to multiply this by 2 to the power of 10. So then for MB we are going to multiply by 2 to the power of 100, and the pattern goes on. In the main function, we have file size variable. We have declared it in a floating value, and then we are printing that value in terms of gigabytes with 2 decimal places, and we have this expression file size divided by GB, and let's run it and see what is the output. And you can see the output is 3.73 GB. So this big number is converted and printed in very readable format. So same way, I'll show you one more example. If we have a college where we have different roles, for example principal, then different departments, and you want to find out different roles which are having different access. So let me show you the code. Let me just remove this line, and in the constant block we'll have some variables like is principal equals to, we'll have 1 colon 1 bit shift operator iota. So these are different departments: computer science, information science, MBA, MCA, ECE, and this is the is principal variable, and we have is college and can go accounts. So these are different access rules for this particular role. It is principal, and let's have one variable here. So we'll have a variable of type byte. So name of the variable would be roles. The type of it will be a byte. So byte is an alias for unsigned integer 8. And what we'll do, we have 8 access rules here: 1 2 3 4 5 6 7 8. So we'll have is principal, or can go accounts, or can go MBA. And what I will print here is %b, that is for byte, and we'll print roles. So let me explain you this code. So in here I'm having 8 access roles with entities in college. So there are like is principal, is college, etc. So I'm bit shifting 1 by 0. So right now iota is 0 for the first iteration. So 1 bit shifted by 0 would be 1. So is principal will have value of 1, and this will be in the form of bytes. Then for is college, it is bit shifted by 1, so the value is 2. Then next is by 2, so the value is 2 raised to 2, that is 4. So this will have value of 4. Then this will have 8. Then this will have 16. Then this will have 32. Like that it will go on and on. So then in the main block, I'm combining 3 constant using OR symbol. So if any of them is true, then that bit will be 1, and that would be saved or represented in the byte. If you want to learn what is byte and how it works, you can Google it. So the output is for this. Let's run it and see. The output is a byte in which you can see 100101. So in here is principal is having, let me show you, is principal is having 1 value, so that is here at units plates. Then we have can go accounts. So can go accounts has value of 4, so that is at this place, that is the third bit from the right. Then we have can go MBA, so its value is 32, so that's why it is having at the last place. So you can see that we have stored a lot of information about the user roles into a single byte, that too very efficiently. So instead of using different variables for each and every one. We have used bit shifting to store all this access role information into a single byte of size 8 bits. If you want to check if the given role is valid or not, then let me show you how to do it. So what we'll do in the printf, let's copy this and let's print it here. So instead of printing roles and in the byte, we will put, we'll check if the user is principal or not. So if is principal, then question mark, then we'll have %v, that is value, and we'll check is principal, and we'll use AND operator. So AND and OR are used for it, those are bitwise operators used with bits. So we'll check is principal with this roles variable. So what this will do, this will check the bits which are true in both of them, and whichever are true, those will be kept and all others will be made 0. So we'll equate it to the is principal. So if you go ahead and run this, we get is principal is true because is principal is present in roles. So and would be 1, that is true for that, and is principal also has 1, so both are equal. So what if you want to check if it is not there? So we'll copy this line, we'll comment this, and let's check if something is not there. So is college we don't have, so let's copy this. So let's check for is college. So instead of is principal, we'll put is college, and in here also is college. So if we go ahead and run this, we should make this as is college. Let me clear this and run it again. So is college, you can see it is printing false because the AND operator gives false for this because it is not present in the roles byte. So what is happening with the AND symbol is that it is called a bit mask, in which only the bits which are true will be kept and the remaining are made 0. So is principal is 1, so that it is left, and is compared with 1, so the output is true. So this is all about constants. So in the last video we had seen about constants in Golang, and in today's video we'll look at the arrays and slices of Golang. So let's get started. So in this video we'll look at arrays and slices. So in the arrays we will see how to create them, then how to use built-in functions with arrays, then how to work with arrays, and next one is slices. So slices are based on arrays only, and we'll follow the same similar approach. First we'll see how to create slices from the arrays, and then the usage of built-in functions, and then how to work with slices. So in Golang, an array is a numbered sequence of elements of a specific length. To make you understand better, I will show you the code. So let's open our Visual Studio Code, and in here, what if we had marks of 3 subjects, for example. So if we had mark 1 colon equals to suppose 80, mark 2 as 90, and mark 3 as suppose 100. And in this way you are saving the marks of 3 subjects in 3 different variables. So what if we had a type of collection where you can store all these marks in only one variable? So that thing is called as arrays. So normally we do mark 1, mark 2, mark 3, and this works, no doubt. You can see 80, 90, 100 is printed. So how we can work with arrays is, it's a simple approach. What we'll have, let me show you. Instead of 3 marks, let's create one marks variable, that is equals to, we'll open the square brackets. Inside this we want to give the size of the array. So for example, we have to save marks of 3 subjects, so we'll give 3 here, and then the type of the data type of the variable, so in our case it is integer. If you have string, you can give string also, and if you have float, you can give float also. And then we can give values by using initializer operator, so that is curly braces. So in here you can give your marks 80 comma 90 comma 100, and while printing you can just call marks here, and that's all. It will print marks of all 3 subjects. So let's see. You can see 80 90 100 is printed, and in here only 1 is required because we are printing marks as a whole, as a collection. So you can see 80 90 100 is printed. So how we declare and initialize array is very simple in Go. So this is how you can use arrays. You can see here that we have given the number of elements as 3 in the square brackets for the array. So what if you don't know the number of elements in your array, if it is very large? So what you can do is, instead of giving it 3 here, you can give 3 dots here. So what this will do, the Go compiler will create an array based on a number of parameters you have passed in the initializer, that is this. So depending on number of parameters passed here, it will automatically create array of that much size, so that you don't need to worry about the array size. So this comes very handy when you are working with large array, and you can see it is printing 80 90 100. If you have added like 1000 here also, or 330, you can see it is taking the elements as 5. So what if you want to create an empty array? So for that, what you can do, let's remove this. We can use var keyword, and we'll create an array of student names as s names, and we'll have 3, and the type of that array will be string. And if you go ahead and print this array, you can see it is an empty array. So we have created an array that is empty and which can store 3 string values. So let's add some values in this array. So for that, what you can do, we'll call this s names, then we'll use subscript, and we'll give the index which you want to use. So the index starts from 0, so at 0th place we'll have one name, one student name. Let's give it as Gunesh, and another, let's say at 2nd place we want to have Muhammad, and let's say we forgot one, so at 1 place we'll have Raju. So the 3 strings are added here, and we can go ahead and print them. We can use println, and we can pass here our s names array. And if you go ahead and run this, you can see it is printing Gunesh, Raju and Muhammad as a single array. Let me clear this, and let me remove this empty array string. Let me show you again. You can see it is printing Gunesh, Raju and Muhammad, and since we have given this in this order, it is printing like that. We can make it as 1 and make it this as 2, and it will print as Gunesh, Muhammad and Raju. You can see here. One more thing is that if you want to print a specific element from the array, you can give the index of that element here also in the print statement. For example, I want to print 0th element, it is first element in the array, and if you go ahead and run this, you can see it is printing my name. So this is how you work with the arrays. Now let's look at the built-in functions. So if you want to print the length of this array, you can call len function. So we'll use len and we'll pass s names as parameter to length function. If you go ahead and run this, you can see it is printing 3 because we have 3 elements in this array, or you can say it is having size of 3. One thing you have to remember that you can create an array of any type, but you have to keep in mind that it consists of same type of elements. For example, if there is an integer array, then it can only store integer values. For example, I have made a string array. It should not be able to store an integer value. If you go ahead and run this, it will give error. Cannot use 3 type untyped int as type string in assignment. So you will get an error. So that's why you have to use the array type which you have created like string, then you have to give string only. Now let me show you an example of two-dimensional array. So these are all of one-dimensional array. So what happens in two-dimensional array is you have an array of arrays. Let me explain it. So let's create an empty array, or we can use var keyword for that, and we'll name it matrix 2D, and it will be of size 2, that is 2 by 2, 2 rows and 2 columns, and it will be of type integer. Okay, and then we can assign values to that. So matrix 2D, at the 0th index, or you can say 0th row, we want 2 values, that is 2 columns we have, that's why 2 values, and of type integer, and inside the curly braces we can give the values. So let's say 0, 1. Same way we can give for matrix 2D first index, that is the second row. It will also have 2 columns, and it will have integers, and it will have 1, 0. If we go ahead and print this, fmt dot print ln, inside that give matrix 2D, and if you go ahead and run this, you can see it is printing an array which has subarrays. So 0 and 1 are part of an array, 1 and 0 are part of an array, and these are included in square bracket. That means these are of type arrays and arrays. So it's a two-dimensional array. You can also use shorthand operator for this. Instead of writing this big one, you can use, suppose, let me make this as comment, and what I can do is which we will equate it to, let's say we have 2 rows, 2 columns, and of type integer, and that will have two columns, and those will have values as should be integer here, and 0, 1, and comma will give another 2 columns, that is will have integer, and it will have 1, 0. In this way also you can create. So these are the two ways in which you can create an array. If you go ahead and run this, you will get the same result. So these are two ways, and let me show you how you can pass arrays. So let me clear this, and in here we'll have one array, let's say array 1 colon equals to, we'll have 3 dots here, and then we'll have type of array as integer, and we'll initialize the values. So 1, 1, 1. So array size is 3. And next we'll have array 2 colon equals to, we'll copy the array 1 inside array 2. And for example, if you want now to edit the value of array 2, and at the 0th element you want to add suppose 0, and if you go ahead and print this, we'll print first array 1, and the same way we'll print array 2. And if you go ahead and run this, let me clear this first, and if you go ahead and run this, we'll get a result like this. So first array will have 1 1 1, but the second array will have 0 1 1. So what you can see here is that it has created a copy of array 1, and in that it is pasting the value as 0 at 0th index. But what we wanted is it should have changed array 1 also, because we are copying array 1 into array 2. So how we can do that? And we don't need to create an extra array for this thing. This is okay when the size of the array is very small, but when you have a big array, at that time it will create performance issues. So we want to evade those things. So what we can do, we can use pointers. So pointers are present in C and C++. So those pointers we can use here also. So what we can do, instead of directly passing array 1 into array 2, we can give ampersand array 1. So this symbol is called as ampersand, which means we are passing the location of array 1 into array 2. So this will create a pointer. Whenever we are changing the array 2's 0th index as 0, what it will do, it will automatically change the array 1's index, and it will not create a separate copy for array 2. Here you can see it is printing 0 1 1 and 0 1 1 again. So this is how you can use pointers for arrays. So in the last video I had shown you how to use arrays in Golang, and in today's video we'll look at slices in Go. So slices look exactly like an array, and you can do most of the array operation with slices. Arrays are very efficient and you will be using them a lot, but they have some disadvantages too, such as you have to know the array size at compile time, and array can be of a fixed size. So those are the disadvantages of arrays. And so what slices are actually? So slices are like a projection of arrays, and slices are only a part of array. That means they have an underlying array. So let me show you that in the code. So in here, what we want to do is, if you remove the 3 dots here and make it as only the square and square brackets, then this will be a slice. So this is how you create a slice. Let me comment both of these lines, and let me zoom in so that you can see clearly. So slices are like this, in which first you will have the open and close square brackets, then you have data type like integer, and then you can give your values in a curly braces. So this will go into the slice, and when you go ahead and run this, you can see we got 1 1 1 as a slice. So I will show you two functions which you can use with the slices. First one is len. So inside this len will give arr1, and if you run this again, we can see the length of the array is 3. That is correct. So this was there in arrays also. We can find out the length of the array. But one more function we can use in this slices is capacity. So that function you can give as Instead of LEN, you have to give CAP. So this will be a capacity of your slice. So let me print it out correctly, and let's change it to printf because we have included the formatting string here. And let's run this. So here you can see that the capacity is 3 and the length is also 3. So in arrays we used ampersand symbol for storing the reference to original array and to avoid the creation of a copy of array. So this was a symbol ampersand which we used that was acting as a reference. But in slices we don't need to use that since slices are by default reference types. So you don't need to use this ampersand because slices are behaving differently as compared to the arrays. So what I will do, I will uncomment both of these lines. So we had array 2 in which we had stored array 1, and in array 2's zeroth index we had put 0 instead of 1. And if we go ahead and print this, we can see the 0 is present in both of the arrays. Because this is a reference type, it will automatically change the 0th element of the array 1 also. This you have to keep in mind. So this is a specialty of slices as compared to arrays. We don't need to give ampersand and all. So this is a good thing, and I'll show you this simple way of creating a slice by opening and closing of square brackets. And to avoid the confusion, we can make this as slice 1 so that you understand better. And I will show different ways in which you can create slices. So what I will do, I will just remove these lines and we'll remove this one also, or you can just comment them out. And what we'll do, let's create, instead of S1 I will just keep it A, and A will be a slice and it will have values from 1 to 10. So now we'll create one more slice. It will have a name as B, and in this what we'll do, we'll have A, and we can use open and close square brackets, and we'll have all elements. To have all the elements printed out, what we can do, we can put colon in between the square brackets. So this what this will do is will include all the elements. And if you go ahead and print both of them, let's close these errors, and you can see it is printing the whole slice from 1 to 10. Now I will show you all the different ways in which you can get some particular values or a particular range of values from the slice. So let's have one more slice, C colon equals to, let's say B, and which values we want, we'll have, let's say, from the third index element to all the elements. So to have third element, we can give 3 colon nothing. So what this will do, this will have values or elements from fourth element to the rest of the elements. So the 3 is representing the index here. So 0, 1, 2 and 3. So it will include 4 till it will go to 10. So let's go ahead and print this out really quickly. And here you can see it is printing 4, 5, 6, 7, 8 and 8, 10. Let me quickly make this as 9. And one more way you can do is you can include one more value in here. So we'll have D slice and we'll include C slice, and instead of going like this, what we can do, we can have everywhere A, and we are creating slices from the main base slice, that is A, and in this we'll give two values, or we can give only one value. So we'll have colon and then we can say 6. So what this will do, this will start from the first index element to the sixth element index element. So that is from 1 till 7, but it will not print 7 because it is up to the sixth index element. So it will only go till fifth index element. It will not include the sixth one. So the upper one was inclusive and the below one is exclusive, which means the upper one will have the third index element included while printing, and the next one D will have the sixth index element excluded. So let's go ahead and run this. Before this we have to print also. You can see it is printing from the first element to the sixth element, that is fifth index element, because index start from 0. Now what we can do, we'll have one more slice. We can have it as E colon equals to, we can have base A as a main slice, and we can give here what if you want third index element till sixth index element. So you can guess here what it will do. So it will have values from the third index element to the fifth index element because it is excluding the sixth index element. Let's go ahead and print this out. And in here you can see it is taking only the 4, 5, 6 element. That is because the index starts from third one, that is 0, 1, 2, 3. The third one is fourth, 4 value, and then fifth, then sixth. So it is going till fifth index element, third, fourth, fifth. That is correct. And this is how you can create slices, and these are different ways in which you can create slices. So what if you just edit the value of the base slice? For example, if you give array at the slice, the element at the position third, if you want to change to, let's suppose, 99. So what it will do, 0, 1, 2, 3, that the third index element is 4 will be converted to 90. So let's see what happens here. In here you can see, after showing the slice A, we are just adding the value 99 to the third index element. But what happens is it goes till the base slice A and it converts all the third index element of all the slices. So this is due to the reference style of the slices, and that's very nice. And but you have to keep in mind that when you're working with slices, if you change any slice and two slices are related to one another, then it will change the base slice also. So you have to keep in mind. And another one is, if you have the slicing operation, uh, which works with arrays also. So these slicing operations are same for arrays also. Let me show you that fast. So what we can do, in the empty square brackets, that is for the slices, we can put three dots which will make them as arrays. And if you go ahead and print this out, you can see that it is printing the same way, because the slicing operation works also with the arrays. And in today's video, we'll look at how to use built-in functions of Golang with slices, and let's get started. And in here you can see that I have shown you how to create slices in different ways in the last video. So today's we will look at the built-in functions in Golang which we can use for operations, doing operation with slices. So the first one is make function. So to create a slice we can use a make function, and it takes 2 or 3 arguments. So let me clear this earlier code. Let's name our slice as S, and let me remove this, and we'll call make function. Inside make function, the first argument is the slice. So we'll have our open close square brackets, then we'll have our data type, that is integer, because we are creating integer slice, comma, we have to give the length of the slice. So for in our case we'll use 3, and then let's just print this slice. So we can see our slice is printed as uh, length of 3, and it has 3 zeros. Let's see the length of the slice. So for that we have a built-in function called len. We'll call len function, and it will take the slice as an argument, and we'll copy this line and we'll paste it here, and we'll use another variable, that is capacity. So this is a function actually, and we can type it as cap, and what this will do, it will tell the capacity of the underlying array of our slice. So I'll explain you afterwards what these are and how it differs from length. So right now it is the length of the array, length of the slice is 3, because it contains 3 zeros or 3 elements, and the capacity is the underlying array, and in our case right now it is the same as the length, but it need not be. Capacity can be more than the length of the slice. So while creating the slices in the make function, it can take a third argument. As I told you earlier, the third argument is the capacity. So we can create a slice with 3 elements, but the underlying array which from which the slice is removed, that can be of a bigger number. So for this one we can give 100. So this slice will have an underlying array of size 100. So capacity is the total number of elements the array might have, that is underlying array. But we are only creating a slice of 3 elements here. It's like taking a slice of a big cake, and this is very useful because unlike array where we have fixed size, the slices don't need to have fixed size. You can add and remove elements from them. So now if you run this, it will show capacity as 100 and the length is 3. So let me just remove this make function, and we'll just create an empty slice in normal way, that is literal way. So we have open close square bracket, and we'll use int, and we'll open and close the curly braces. So this will create our empty slice. If you go ahead and print this, you can see earlier in make function we had given the length as 3 and it was showing us 3 zeros, but right now we have created an empty slice, so it doesn't have any value. So length is 0 and capacity is also 0. So what if we want to add a value to this? So adding a value to the slice, we can use a built-in function called append. So what it will do, it will add the value which we desire to the slice. So let me show you that. So below this, what we can do, we'll call the slice s equal to, we'll call the append function, and inside the append function we'll give first argument as our slice which we have, and then the value we want to add. So we want to add 1, and then what we can do, we can just print the slice and the length and capacity of the slice. So if you go ahead and print this, you can see the earlier was length was 0, capacity was 0, but now we have added 1, so it is showing it here, and length and capacity is 1. What if you want to add more values? So suppose if we had more values like 2, 3, 4, 5, you can see that now the length of the slice is 5 because it contains 5 elements, but the capacity, as you can see, it is 6. So what is happening here is, in the beginning the capacity was 0, that is the capacity of the underlying array, not the slice. This is done by the Go compiler. It finds out how much size or how much memory should be allocated to the particular underlying array to store that particular slice. So in our case it was 1 in the beginning, then we added more elements, the length of the slice became 5, and the earlier it was 1, so it need to create a new slice of 5 elements, so it added plus 5, so 1 plus 5 became 6, so capacity became 6. So every time it creates a new slice, so the underlying array is copied and a new slice is created. So this is very memory intensive, and it can give you a performance hit when you're working with large size arrays and slices. So to overcome this, what we can do, we can give the capacity of underlying array before only. So for giving that only, I had shown you the make function. The make function has the third argument as the length of the capacity. So we can give that capacity number there to avoid this. Otherwise, the Go compiler will automatically create new copies of arrays, the underlying arrays, and it will become very cumbersome afterwards. So what if we create this using a make function, and we can give int, then we can give, we have to have elements size as 5, and then we can create capacity as 100. So if we do this, there will be no problem, and you can see in the beginning it was empty slice which contains 5 zeros, then we added 1, the length became 6, then we added 1, 2, 3, 4, 5, then the length became 10, and the capacity is 100. So this is how you overcome extra memory operations which are done if you are not using the make function. So if you want to add 2 or 3 slices, that is concatenation, you can do like this. So let me clear this out. Instead of giving like this, what you can do, here we can pass a slice of int, and in that we can pass 2, 3, 4, 5, and if you run this, you'll get an error because append function can only take the integer values and not a slice value. So what we can do, we can use a spreader operator that is used in JavaScript. So same thing we can use in Go also. So for that, what we need to do, when the slice will end, that is the curly braces, we can give 3 dots. So what this will do, this will dereference or decompress the slices into the integer values, and it's called a spreader operation in JavaScript. So if you go ahead and print this, you can see it is adding 2, 3, 4, 5 to the already created slice. So this is very helpful if you are working with concatenation, and it will avoid the errors. So now let's look at the stack operations. Using stack operation, what we can do, we can push elements on the slice and we can pop elements from the stack. So append function allows for pushing elements on the slices. Now how to pop elements. So for that we will look at shift operation, in which we will remove element from either side of the slice. So let me give a quick example. We'll just remove this code and we'll create an empty slice. In that we'll pass 5 values, and if you want to remove the first element, what we can do, we can create one more slice named R, and it will have values from the beginning. So we'll start the index from 1 till all the elements. So it will remove the 0th index element, that is 1. So we want to have the slice of yes, and if you go ahead and run this, we can see 1 is removed and only 2, 3, 4, 5 are present in the new slice, that is R. So what if you want, so this was for pop element from beginning. If you want to pop element from end, what we can do is we can just take all the elements from the beginning and we'll call len function. So it will get the number of elements in the slice and we'll just minus it by 1, and if you do this, you can see the last element is removed in the new slice. So this is okay, but what if you want to remove element from the middle of this slice, that is 3. So for that you will need to use concatenation. So what we can do, we can call append function. So append function will take 2 arguments. So first argument will give the slice, that is first slice. So it will start from the beginning and it will go till second index, and then we'll have the slice from the third index till the last index. So what we can do for this, after we can put, let's just run and see. I'll copy this and I'll see, paste it here. If you go ahead and run, we got an error, that is we didn't use sped up operation. So you have to give 3 dots here and just run it again. And here you can see first array was 1, 2, 3, the slice was 1, 2, 3, 4, 5. Then the slice, we removed a middle element, so it became 1, 2, 4, 5. And then in the end we printed the slice again. So here you can see now the original slice has changed, because I have already told you in the beginning of this video that the slices are reference type. So whatever changes you do to the later slice will reflect in the base slice. So here S was our base slice, so we changed the R slice, so it went ahead and changed the base slice, that was S. So here you can see we removed the third element. So in the original slice also, that is S, the third element is replaced by 4, and the fourth element is also replaced by 5, and last element is as normal is 5. So we have to keep in mind that when we are working with slices, this thing can happen. So we have to be beware of all those things when we are working with slices. This is not like array, in which it creates new copy of the array when you are changing the array elements. But in slices, whatever you change, it will reflect in the original slice. Today's video will look at Golang maps. Today's video contents will be, we'll first look at how to create maps, and then we'll look at the use of built-in functions to manipulate the maps. The last thing we'll look at is how to work with the maps. So let's get started. What is map? So in simple words, a map is a data structure which maps different keys to different values. So let me show you with an example. Let me zoom in, and in the last video we had seen about the stack operation with the slices. So we'll remove everything from here, and in here we can create one new map. The name of the map would be country population colon equals to, we have to give map keyword, and it will have open and close square bracket, and inside the square brackets we have to give the data type of the keys, and outside the square bracket we have to give the data type of the values. So since countries have a string in the name, so I'm giving string as the data type for the keys, and the values are actually the population, that is the number, so we are giving integer, and we'll open and close curly braces. Let me put it down. So in this we have to give the keys and values. So there is a distinct way of giving the keys and values. So we have to type the key, so inside inverted commas, double inverted commas, because it is of type string, so we have to give India as the first country, then colon will come, and then we have to give the number, that is the population of the country. So for the simplicity I'm giving as 123, so you can think of it as a 123 crore, then comma, then give next one, for example USA. So this is how you create a map, and this is a literal syntax for creating a map, and you can just print it out using fmt dot print ln. Inside that will give country population. So done. So if you go ahead and run this, we got an error saying that unexpected new line expecting comma. Let's check where it is expecting the commas. So here you can see we had given comma in the end also. So now it is creating a map and it is printed here. Let me zoom in. So map looks like this. So map keyword is there. Then inside that, the square bracket, we got the keys and values. So all the 5 countries are printed here: China, France, India, Pakistan, and USA. And you can see here that we had given India first, but in here it has come as third. So I'll explain afterwards why it has been like this. So let me close the terminal and let's look at the next example. Before that, we can give different types of data types in here for keys and values also. So we have to consider some allowed types for keys in the map. So you can give here as boolean, and you can give all numeric types for the keys. Numeric types include the integer, float, double, etc. Then you can give strings as we have given here. Then we can give pointers, structs, arrays, channels, and the things which are not allowed inside the keys data type are slices, maps, and other functions. So we can't include them in here while giving data type of the map. So let me give an example for that. So if you go ahead and put slice, so this is a slice syntax. If you remember, open close square brackets, the data type is integer, and if you go ahead and run this, you will get invalid map key type integer. And you can neglect this because this is for the string, but the first error, that is invalid map key type as integer, that is a slice, is not allowed. So in place of slice we can put 3 here, so this will become an array. And if you go ahead and run this, that error has gone, and now we can see, instead of removing let me just comment this. If you go ahead and run, let me comment this also. Can do here this one. If you go ahead and run, you can see it creates an empty map. So you can see that arrays are allowed but slices are not allowed while creating maps, and that too in the form of keys. So let's look at the different ways to create map. So we had seen this way, which was the literal syntax. And now let's look at another way, that is by using the make function. So for slices we had seen that we can use make function to create map slices. Same way you can use make function to create maps. So what I will do, I'll copy this, paste it here on top, and we'll put colon equal to, we'll call make function, and inside make function we have to give the map and data type, that is string, and it will have integer as values. So this is how you create a map. But when you are going to use it, you can just give it here, country population equals to, you can call that map with string and integer, and you can just give the keys and values inside this. So this is very helpful if you don't have the values and keys beforehand, and if you want to add these values inside a for loop, etc. So you can do this type of thing where you can give an initialized map using make function, then afterwards you can add those values to that. So if you go ahead and run this, you can see it is creating a map like before with all the values of the countries. So make function can also take second argument. It is the initial capacity of the map. So in here I can do, I can add 10. So what this will do, this will create a map of for 10 elements. So right now we have 5 countries, so it will create a map for 10 countries, but it will not be displayed here, but it has the initial capacity of 10. So as soon as you reach 10, it will automatically increase that depending on the length of the map. Now let's look at the how to manipulate the map. So the first thing I will show you is we can just print the population of a particular country. So how we can do that? We have to give the country population, then we have to give square brackets. Inside square bracket we have to give the keys value. So which country you want to print? For example, I want to print India, so we can give India as the key here. And if you go ahead and print this, let me just clear this out. So you can see India's population is printed here as 123. Another thing is, what if you want to add values to this map? So that also you can do. What you have to do is we have to call the country population, that is the name of the map, and inside here we have to give the key which you want to add. For example, I want to add the Russia, so we have to give the string Russia, and we have to equate it with the value we want to include. So like for example 654, that is the population I want to include for the Russia. And if you go ahead and run this, you can see Russia is added 654 in the map. So what if you want to delete this Russia or delete an element from the map? So for that there is an inbuilt function called delete. So what you have to do is you have to call delete function. So it will take first argument as the name of the map. So we have country population, comma, the second argument will be the name of the key. So we have Russia that we want to remove, and what I will do, as soon as we add Russia we'll just print it, and as soon as we remove Russia we will print the map. So here you can see Russia is added, and here you can see Russia is removed. So this is how we delete particular element or particular key value pair from the map. So what if you go ahead and do something like after deleting, what if you go ahead and print the value of Russia? So let's check. So it is printing 0 as the value of Russia. So this is an ambiguous situation where we don't know if Russia's population is 0 in the map or it's something else. So let's find out what has happened here. So I'll remove both of them, and instead of Russia, if you go ahead and print like USA, it will print the value of USA very well. So what if you misspell the USA spelling? If you just give US, if you go ahead and run, it will show 0. And one thing it will be like we don't have that particular value inside the map, so that's why it is printing as 0. So to verify that, we have something called as comma OK operator or comma OK syntax in Golang. So it is used by many developers to check if a particular value is present in the map or not. So let's go ahead and let me show you that. So what I will do is I will just we'll take a variable called temp, then we'll have one more variable called OK, which will equate to, that is colon equal to, we'll give country population, and inside here we have to give the key. So for example US, so we'll check if US is present or not. So we have misspelled here purposely. In here we can just go ahead and print the temp and OK's value. So let me clear the terminal, and if you go ahead and run this, we get temp's value as 0 and OK as false. That means the particular US is not present in the map. So if we go ahead and just turn it into USA, and if you go ahead and run this, you will get the value as 342, that is the US's population, and you can get true, that is because the particular USA key is present in the map. And what if you want just to check if the particular key is present or not? We can just remove temp and we can just put an underscore. So what this will do, this will be a write up operator in which the value of this particular variable is discarded, and we are only taking the OK into consideration. And if you go ahead and run this, it will say USA is present, so that's why it is saying true. So this is how you use comma OK operator or syntax to find out if a particular key is present in the map or not. Now let's look at one more built-in function. So this built-in function called as len. So this will just print out the length of the map. So that is how many elements are present in the map. So what we'll do, we'll just remove this line, and instead of OK, we'll just call len function, and inside this len function we'll just print country population. So if you go ahead and run this, let's clear this, it will print 5 because there are 5 countries present in the map. One more thing is that maps are reference types like slices. So if you change a derived map, then the changes will reflect in the base map also. So this you have to keep in mind. So I will give an example for that. Let's create a copy of this country population. We'll name it as CP colon equals to, we'll call country population, and what we'll do, we'll just delete one element from this. So we want to remove USA from that. We'll give USA, and we'll just print out the CP, and also we'll print out the country population in the beginning, and after deleting from the CP, we'll just print out the country population. So if you go ahead and run this, so in the beginning we had 5 elements, that is 5 countries, and we had USA in the last. Then in the second line we can see that its CP is printed, in that we have deleted the USA. And in the third line, this is the country population, and in this also the USA is removed. So you can conclude that the maps are reference types. So if you change anything in the derived map, then it will change in the base map. So you have to keep this in mind when copying in the maps and manipulating them, as it might lead to bugs afterwards. So this is all guys for the maps. In today's video we'll look at structs in Golang. So what are structs? So Go structs are typed collection of fields, and they are very useful for grouping data together to form records. So let me show you an example. So in here, above main function, we'll create one struct. So the literal syntax is we have to type type, that is type. Then we have to give the name of the struct. In our case, we'll give it celebrity. Then struct keyword, and then open and close curly braces. So this is how you declare a struct. Inside here you can give the struct fields. So first struct field will be given as age, and data type of that would be int. Second would be celebrity name. You can see I'm using camel case here, and its data type would be string, and we don't need to give comma here. Only when we are initializing we have to give commas. And third would be co-authors, or you can say co-actors, and this will be of type slice of string. And this is how you declare a struct. Now let's initialize the struct. So we have to create a variable for the struct. So let me name the variable name as a celebrity. So this will be a struct variable, and then we will have to initialize it with colon equal to, then name of the struct, in our case it is celebrity, and then open and close curly braces. Inside here we have to give values to the struct fields we have specified here. So first would be age, then colon, we have to give the value of the age. So we'll give 55, then comma, because we are in initializer block we have to give comma after every struct field. Then we have to give celebrity name, that would be, let's say, Vin Diesel, comma, then we have to give co-actors names. So this is a slice of string, so we have to specify it as slice of string. So we are giving, then we have to open and close curly braces because it takes more than one argument. So we'll give two argument here, or two values here. One is Gal Gadot, she is a beautiful actress. Then we'll give Paul Walker, and after your co-actors block is closed, oops, let me close this, give a comma after your co-actors block is closed, and after the celebrity variable is created and initialized, we'll just print the values. So fmd dot print ln. Inside here we have to give the name of the variable, so a celebrity, and this is all it. And here also we have to give a comma after Paul Walker. And now if you go ahead and run this, let me clear this and let's run. You can see we got the values as first as the age, then the actor's name, then we got its co-actors names. One more thing we can do is, and we have to keep in mind that structs are the only collections in Go which provides you to have different type of data fields at one place. So here you can see we got age of type integer, then we have celebrity names as string, then co-actors as slice of strings. And if you look at the arrays, slices and maps, all these collection types have to have same type of data types in them. But for structs, it's not mandatory, and we can have different types of data types in one struct. So now let's look at the dot syntax to get particular values from this struct. So for example, I want to have the celebrity's age. So what you can do, you can put after the structure variable, we have to give dot, then we have to give age, and if you run this, you can see it is giving us 55. What if you want to print co-actors? It gives Girl Gadot and Paul Walker, and you can see there is no comma in between. So we can just fix it because slices are indexed types, so we can give 0 or 1 here. If we give 1, it will print Paul Walker, as you can see. Now let me show you how to use positional syntax. So here you can see we have given specifically the data types, the structure fields, and then the values. But there is one more way in which you can specify this. So this is called as positional syntax. So you can just remove this structure fields or struct fields, and if you go ahead and run this, let me remove this. It still prints the values, as you can see here. So this might look very intimidating, but you shouldn't use it in daily practice, and there's a very good reason for that. So for example, in here a new change has come. For example, another developer adds, so for suppose after age, movies are added as slice of string, and if you go ahead and run this, we'll get an error, cannot use string literal type as type string in field values. And you can see too few values in celebrity literal because we have not given the movie's values here, so it's throwing us an error. So whenever you are using a positional syntax, keep in mind that we have to give the values of each and every struct fields. And if you do this now, and also we have to open and close curly braces, and if you go ahead and run this, it is printing us the values, and you can see it is printing that slice is empty slice. But what if another guy comes and changes this or removes this and adds it here below celebrity name? If you go ahead and run this, it will show us as a string error. Put this below this, and for example, if it is changed here and it is given here like that, and if you run this, you can see the age is 55, but the co-actors, even though we have given here, it is not printed here. Vin Diesel is printed, and movies, in place of movies, it is printing us the co-actor's name. So this is what happens if you use positional syntax, and if another guy comes and changes the values of that. So this you have to keep in mind. And if you go ahead and add back those name of the fields to struct initializer, we get the correct output. Let's say we had movies below celebrity names, and if you give movies here, we don't need to give colon here, and if you go ahead and run this, it will still give us a values, and it is giving us correct values. As you can see, age is 55, celebrity name is Vin Diesel, and movies are empty, and the actor's name are given here. So it is taking this from this structure field. And what if you remove these movies and run this? If you remove that also, it still runs, and it will print as empty. But whereas if you are using positional syntax, it will give an error saying too few parameters passed to the structure or struct. So I would recommend you to use positional syntax only if the lifespan of the struct is very less. That means you can make use of it in anonymous structs, etc. But for normal structs, try to avoid it. So now let's look at the naming convention of the struct. So you can see that celebrity has C capital. That means it is exported and it's visible to other packages. But the struct fields are starting from lowercase letter. As you can see, age, A has small letter, C also a celebrity name. So these are all starting with lowercase letters. So that means those are not exported and are valid in this main package only. So those are imported in this package only. Since both the struct and the main function are part of this main package, the data can be used in the main function. So this here we can use the main data in the main function. If you want to export the data fields of struct, you just need to make their first letter as capital letter. So if you make it as capital letters, you can make them get exported, and keep in mind that you have to export this also. And this will work just fine. And these values will be exported and other packages can see these values. Now let's look at the anonymous structs. So you can see that in here I have specifically created a struct by defining the type celebrity struct. So this is the specifically I have given the struct name, etc. But there is another way in which you can create structs without explicitly specifying the name of the struct, and that is called as anonymous structs. So let me give an example. So I'll just fold this and you can just comment this out, and inside here what we can do, we can create a struct. So we'll give a structure variable first. So we had a celebrity colon equal to, we have to give struct keyword curly braces. So inside the curly braces we have to give the structure of the struct. So it will have the fields. So we will have age and data type of that is integer. So keep in mind these curly braces are for declaration syntax, and then the next curly braces would be the initializer syntax. So here it will give as age colon 55. So this is how you create anonymous struct. And if you go ahead and print this, you can see it is printing 55. So this is useful when you want to work with data for small amount of time and don't need to export the struct to other packages. Also, this type of struct don't have names to make a call to. So that's why they are anonymous structs. Anonymous structs are not reference types. If you copy this struct variable a celebrity into another variable called b celebrity, and then you just add value as 95 for example, and if you go ahead and print both of them, in here we have to give dot age, and if you go ahead and run, let me clear this, you can see first it is printed as 55, then it is printed as 95. So I shown you in the maps it was of type reference type, so every time it would just change the base map, but here it is creating new copies of those structs, and it can be memory intensive depending on the struct size. So you have to keep in mind. So what if you want to have it as a reference type? You need to just pass ampersand here, and this will become reference type. And if you run this, you can see both of the values are same, 95, 95. And in here it is not creating a separate copy of that struct. So in today's video, we'll look at the composition in Golang. So the Golang programming language is not a traditional object-oriented language like C++ and Java. A key feature supporting traditional object-oriented design is inheritance. Inheritance supports sharing of code and data between related objects, and we have classes and objects also. Golang does not support inheritance, however it does support composition. So what is composition in general? So in general words, composition means putting together. For example, composition of a car. A car is composed of wheels, engine, doors, and various other parts. Composition can be achieved in Golang by embedding one struct type into another struct, also called as embedding. So now let's look at an example of composition. So this is our earlier code of struct. What I will do is I will comment all this so that I can add the composition code below this, and I will share the link of the GitHub repository in the video description so that you can also try it out. So we'll just create a heading as composition in Golang. Now we'll call package main, then we'll have import statement for fmt library, then we have function main, and now we'll declare two structures. So the first structure will be vehicle, and this will be of type struct, open close curly braces. Inside this we'll give two struct fields. First would be the name of the vehicle, so we'll give name, and the type would be string. Then next would be type, so this will be a vehicle type. This will be of also string type, and below this we'll create one more struct. The name would be car, and type would be struct, open close curly braces, and inside this we'll give two struct fields. First would be max speed, that is of the car, and we'll be giving the value as float32. Then next would be fuel type. So what is the type of the fuel the car uses? So this will be of type string. And now I will show you how to embed this vehicle struct into this car struct. So you have to give the name of the structure you want to include. So we will include vehicle. Just give it as this. So what this will do, this will embed this vehicle struct into this car struct. Now in the main function, what we can give is we can create an instance of car struct. So we'll name it as C colon equal to, we'll call the struct car, open close curly braces. So this will create an instance of car struct at C. Now we can use the instance as C dot, we can call the struct field of vehicle structure. So it will be name, and we can give value as Ferrari. Then next we can give as C dot type equals to convertible. Then we can give C dot max speed equals to, let's say, 250. Then we can give C dot fuel type equal to diesel, and in the end we can just print it out, and you can just print C, and this is done. So you can see that it is giving us warning because we have given it as C as capital and V as capital of vehicle and car. That means it is getting exported. So now just we'll go ahead and run this. And you can see the output as inside curly braces there is embedded curly braces and it is having Ferrari and convertible, and next is 250 and diesel. So this embedded means that it is coming from the vehicle struct and it is embedded. You can do one more thing. You can use dot syntax to get a value of particular struct field, for example name, and you can just go ahead and run this and it will print Ferrari. It looks like car is inheriting the properties of vehicle, as you can see here, but it's not. In here, Golang is automatically passing the control to embedded vehicle struct for the name field, as you can see here. And car is not a vehicle. It's an independent struct that embeds it, as you can see here. Overall, it means that car is not a vehicle, but car has a vehicle. So has means composition. As you can see, car has this vehicle. It means composition. And if it was car is a vehicle, it would be inheritance. But there is no inheritance in Golang, so that is not present. If you want to make the car as is a vehicle, then there is a concept called interfaces. I'll show you that in the next videos. But keep in mind that this is the use case of composition in Golang. So now let's look at the literal syntax. So for literal syntax, what we need to do is, we don't need to give like this. This is helpful if you're going with this normal syntax. But if you're going with the literal syntax, when you are creating the instance, it will be like this. And inside this, you have to give the details of the all the structure fields. So first will be vehicle, then will we have a colon, and this will have, since we are embedding the vehicle, we have to give the structure of vehicle. So inside here we have to give name, colon, the value of that will be Ferrari, comma, because this is an initializer block and it's literal syntax, then type, colon, we have to give the string as convertible here, and after this we'll have to put a comma, and then we have to give max speed, colon, 250, comma, fuel type, colon, diesel. Now if you go ahead and run this, let me clear this out, it will print the same value as Ferrari convertible embedded as a vehicle inside a car, then 250 and diesel, that is of car struct. So keep in mind that we are working with literal syntax. We have to provide the internal structure like this of the vehicle structure. And when we are not using literal syntax, we can directly call the struct variables using dot syntax that I have shown you already in the beginning of the video. In today's video, we'll look at Golang tags. So we'll look at how Golang tags can add meta information to structures and how we can take advantage of those things. So tags are a way to attach additional information to structure fields. Let me show an example first. So in here we have a file named tags.go. So in here we have to create a structure. So we'll name the structure as user, because we'll be using user structure field, for example username and password, and this will be a type struct, open close curly braces. Inside this we have to give structure field. So we'll give two struct fields. So one is username, and it will be of type string. Another one is password, and this will be also of type string. So now you will ask me about how you can use tags with a structure. So tags are started with, or tags are written in Golang with backticks. So we want to include two backticks. Inside these two backticks, we want to give the tag name, and keep in mind this is backticks and this is not single inverted commas. And in here, we will give a tag as valid, and we can give another tag also here just by giving space in between the two tags. For example, minimum, or we can say max size colon 20. So this username will have maximum size of 20 characters. Same way we can create tag for password. So minimum size of the password should be 8. And now how we can use these tags in our code, because we have only declared them, we have not used them. For using them, there is no straightforward way, and there is no object creation and calling that structure fields. So we have to use a package called reflect to work with the tags. So let me show you. First we'll create an instance of the struct username user. So we'll name it as u colon equal to, we'll call the user, and we'll create an empty instance. Then we'll create a field for or you can say a variable for tag. So t colon equal to, we'll call reflect package. Then from the reflect package we'll call one function called type of, and this function will take the structure object, that is u. And now we want to create a field. So we'll create a field variable colon equal to, we'll just call tag field tag object. So t dot, we'll call field function from that, and this will take the index of the struct field. So username will have index as 0, password will have index as 1. That is depending on the positional syntax. So we have to get username, so we'll give 0 here as index. Then we have to just call the fmt dot println to print the tag value. So we'll just call field dot, we'll call tag. And if you go ahead and run this, we got an error. We have to search where it is. So we have to give these keys in double inverted commas, not keys, the values. So these are key and value pairs. And one more thing is func main here. And if you go ahead and run this, this should be F capital. Let me clear this and we'll run it again. And we got the tags valid and max size is 20. So what if you want value of this max size tag? So for that, what you can do, we'll just copy and paste this, and after tag you have to give tag dot get function. So inside this we have to give the tags key. So we have to give max size, and if you go ahead and run this, since we have two values here, just remove one. Now we'll run this and we'll get 20 here. One more way of If you don't want to include index here, what you can do, this is an alternative. We can call field, or we can create a field variable here, comma, underscore. That means this is a write-up operator and we don't need it. Colon equal to t dot field by name. So we'll just call for the particular struct field which you want to include. So we'll use username. Keep in mind that it is given as a string here. And now if you go ahead and let me comment this, run this, we'll get max size is 20. Also we can give here password, and it will give minimum size as 8. So this is how we work with the tags, and there are more advanced usage of tags in struct. For example, we can use JSON libraries or different encoding libs we already get like JSON and BSON, and we can use those with the unmarshal and marshal functions to validate the input we are getting from the forms, etc. And there are different packages also, for example, Go Validator or Go Defaults. So those packages will be helpful for checking the validity of the structure field. So for example, we have given max size, minimum size here, but in there we can get predefined functions, for example, is email or is password, like that, and we can use those with the tags here. Hello and welcome to another video, and in today's video we'll look at the control flow statements in Golang. So the control flow statements are of three types. One is if statement, another is if else statement, and third one is if else if statement. So let me show you with an example. I will take a simple example of if statement. So if we have if and then true, for example, and curly braces, open and close curly braces, this means this if statement will run whenever this value is true, and we can just print it out anything we want. If is true, and if you go ahead and run this, it will say if is true. What if you make this as false? Then it will not run because if is false. So this is a simple syntax of if statement. So let me make it exciting, and what we can do is we'll take two variables. Suppose a colon equal to, let's suppose 10, and b colon equal to 20. Now let's check which one is bigger and which one is smaller. So for that we'll use if statement. If a is greater than b, then we'll say fmt.println, we'll say a is bigger, and if b is greater than a, or you can write if a is less than b, we can say b is bigger. And if you go ahead and run this, it will say b is bigger because b is 20. If you make a as 30, it will say a is bigger. So this is a simple example. So in here I have used relational operators, greater than and less than. We'll also add one more operator. Suppose if a is equal to b, then we will say both are equal, right? And if you go ahead and run this, before that let's make b also 30, and if you run this, it will say both are equal. And there are many other relational operator. For example, if A is greater than equal to B, and then if A is less than equal to B. So these are also relational operators. In here you can see that it is printing all the values. Suppose A is bigger than B is bigger and both are equal. That is because both of them are equal here. If you go ahead and make this as 40, and let's remove this one, let's remove this one, just comment out. And if it is 40 here, then it will say A is bigger because right now it is both are equal here. So these are all the relational operators. Now let me show you some logical operators also. And what we'll do is, I'll just comment here as relational operators, and we put less than, greater than, less than equal to, greater than equal to, and equal to. Okay, and for now I'll comment this out. And now let's look at logical operators. So logical operators are of three types. First one is AND, so that is ampersand and ampersand. Second one is OR, so these are two pipe symbols. And the third one is NOT. So for this example, what I will do is, I'll take one more variable, C colon equal to, let's suppose 50, and we'll make A is equal to 30, 30, 40, 50. So we'll write a code to check which one is greater in among these three variables. So if A is greater than B, and if A is greater than C, then we'll say A is biggest, for example. Same applies for B also. If B is greater than A and B is greater than C, we'll say B is biggest, else here. And if not, we'll say C is biggest, because C is the only remaining variable. So keep in mind that you don't bring else to the next line, you just have to have it the same line. If you go ahead and run this, let's clear this out. It will say C is biggest because C has the 50 value. Or if you make this as 70 as A, if you say A is biggest, then it will say C is also biggest because it is not chaining up with this if statement. So here you can see it is one if statement, then this is chained up to if else statements. Okay, so this is one block of code and this is one block of code. So that's why keep in mind that you have to chain the blocks of code. So if you make this like this, if, else if this one, else this one, if you go ahead and run this, it will say A is biggest. So this you have to keep in mind. You have to chain up the if else blocks. So here you can see I have included all the three types. First one is only if, second one is if else, if, and the third one is else, if else. So these are the three types of if statement you can use, and along with the logical operators. So let me give an example of or also here. And for that, what we can do, we can just comment this out. and let's make it one more variable. If a is greater than suppose 50 or a is less than 100, okay, then we'll say a lies in between 50 and 100. And it will give an error here, because warning here, because we have not used b and c. So let's go ahead and run this. It will say a lies in between 50 and 100. That is because a is 70, and it is checking either one of this condition, either a is greater than 50 or a less than 100. So what if we make it as more than 100, suppose 150? If you go ahead and run this again, it will say a lies in between 50 and 100. That is because it is checking either one of this condition. So it is checking first for a is greater than 50, that is true, and next we will check a is less than 100, it is not, but in between there is a or sign, so any one, if it is true, then it will say, it will run the code that is put inside this block. So this is the beauty of or statements. And what if we have, if you want to show the not statement, let me comment this. And not, you don't need to comment that. And not will work as, if not equal to false, suppose it will print not false is true, we'll say. And if you go ahead and run this, it will print true, because not false is always true. If you make this as true, not true is false, so it will not print true. You can see it is false, because not true is false, so this if block will not run. This if block will run only if this is true. So when this is true, it is only true when it is not false. So not false means it converts false into true due to this not symbol, or it is, you can say, not operator. One more very important thing you should know in Golang is there is something called as in other languages we have exception, try catch exception blocks are there when we can handle the errors, but in Golang we don't have that. In place of that, we can use if statement. So if we get an error, we can check if it is not equal to nil, and inside here we can handle the error. So this is the way you can handle the errors using if statement. So right now it is error is undefined, but in Golang programs you will have these errors which will be coming from different packages and all. And one more thing is that you can initialize a value inside if statement also. For example, if you have a variable called num, you can have num colon equal to, let's suppose 100, then you can put semicolon, so this will create an initializer syntax. Then we can say num is greater than 0, for example, and we can just print it out as a is positive. If you go ahead and run this, a declared but not used because of this. Now if you run this, you will get number is positive. So this is how we can use initializer here in the if statement, and we can check also. We can do all sorts of things here. Suppose num percent 2 is equal to 0, we will say num is even. So this is also you can do. You can say number is a 1. Hello and welcome to another video, and in today's video we'll be looking at switch statements in Golang. A switch statement is a shorter way to write a sequence of if-else statements. It runs on the first case whose value is equal to the condition expression. And switch statements express conditionals across many branches. So let me show an example. Here we have our function name, and what we'll do, we'll create one variable I colon equal to, let's suppose 2. Then what we'll do, we'll just call the switch statement, and switch statement will either have a condition or it will not have a condition. For the beginning we'll just have a condition. For suppose we'll pass I here, open close curly braces. Inside here we have to give our cases. So we'll have one case which will have 1, and then if it is like that, then we'll just print it's 1. Okay, so same way we'll have one more condition. For suppose case 2, and what case 2 will have, it will print 2 in letter format, and then we'll have third condition as default. So if nothing matches, then we'll print its default. So let me explain you first. So this case 1, in the switch we are passing the I, so I has value 2. So the case will check the I's value. So for suppose it is 1, then it will run 1. If it is 2, it will run 2. Let's turn and see. It is printing 2. What if we make the I value as 1? Now if you go ahead and run this, it will print 1. So this is a simple example of how switch case works. Now let me show you one more example. In here we'll use time library. So let's import that, and what we'll do, we'll just comment out this one, and below we'll write, we'll call switch statement, and in here we'll call time library, time dot, from here we'll get function now, then we'll call one more function dot weekday. So what this will function will return, it will return today's weekday, and this will be our condition for switch statement. And inside for the case, what we can write, we'll just check if the time dot Saturday or time dot Sunday, then we'll just print that it's a weekend. And one more case we'll put as default. This will be saying it's not a weekend. So if you go ahead and run this, it will say it's not a weekend. Here you can see that we have included more than 2 expressions in the case statement that you can do provided you put a comma in between these 2 or more conditions. One more thing is that in other languages we have seen that we use break in order to break the cases after it executing, and to not allow all the cases to run, we put break in every cases in other languages such as C, C++. But in here we don't need to have that because the Go language does it implicitly. So only one case will run at a time in Golang. So that you have to keep in mind. So you don't need to give break statement. But you can give break statement if you want to take the control out of this case. For example, if you have one more logic, suppose you have printed fmd.println, for example, hello, welcome. And if you don't want to print this hello welcome and you just want to come out of the switch statement after the printing it's a weekend, you can put break here. If you go ahead and run, this will run, it will not run because it's not a weekend. We just copy this and we can just paste it here. And if you go ahead and run this, it will run it's not a weekend, it will come out. And if you remove this break and if you run this, you can see it is printing hello welcome also. So this is the beauty of break statement. And now let me show you one more example. In this we'll use hours. So using hours we can find out if it is afternoon or it's night time. So let's just call the time.now function t colon equal to time.now, and keep in mind that we don't need to give condition if you don't want. So I'm just keeping this condition that is also allowed. Golang implicitly finds out that we are passing the t inside here because the cases will be dependent on t dot hour, and if it is less than 12, let's suppose, then we'll print it's before noon. Same way we'll have a default, and default will have it's afternoon, for example. If you go ahead and run this, you will get it's before noon because the time is 11:30 right now, as you can see here. And here you can see that the case expression can also be a non-constant. So we are calling functions here, so it's not a constant, so you can also use non-constant here. And you don't need to give switch condition or switch expression here every time. You can just keep it if you want. And one more statement I will show you is fall through. So for example, if we give one more case here, case t dot hour is equal to, for suppose 12, we will just say fall through. And what this actually does is the fall through will take the control from this statement to the next statement. So thank you for watching, and I will see you in the next video. Hello and welcome to Golang tutorial for beginners. And my name is Gunesh Shanbhag, and in today's video we'll be looking at the looping constructs present in Golang. So Go has only one looping construct, and that is for loop. The basic for loop contains three components separated by semicolon. The first component is the init statement, which is executed before the first iteration of the loop. Second comes the condition expression, which is evaluated before every iteration. And third comes the post statement, which is executed at the end of each iteration. The init statement will often be a short variable declaration, and the variables declared there are visible only in the scope of the for loop. Let me show an example for a sum of first 10 whole numbers. So whole number starts with 0. So we'll make a variable as sum colon equal to 0. Then in the for loop, first we'll start with the 0. So I colon equal to, I will say 0. So this is our starting init statement. Then comes the semicolon. The second part is the condition expression. So till what condition we want this loop to run. So we'll want to run this till I is less than 10. That is I is less than or equal to 9, you can say. Then comes the semicolon. And now comes the post statement, that is the increment operator or statement. So we can write I plus plus and open and close curly braces. So this is our basic syntax of for loop. So inside here what we can do, we can just do sum plus equal to I, which will add the value of I to sum after every iteration. And now we can just print out the sum. Let's go ahead and run this. Let me clear this out. And now you can see that the sum of first 10 whole numbers is 45. Here the init and post statement are optional, which means that you can just remove this and place it on above, or you can just remove them completely. And you can also remove this I plus plus, that is post statement, and if you want you can put it here also. So this will also work, and if you go ahead and run this, it will print 45 again. But keep in mind that you can't just remove this semicolon. If you remove these semicolons, the Go compiler will think that I is less than 10 is the initializer syntax or init statement of this for loop. And if you go ahead and run this, it will say syntax error, unexpected curly brace, open curly brace, expecting for loop condition. That's what it means, that we need to have a semicolon so that it will remove the error. Same way goes for the post statement also. It will give the same error, unexpected new line, and it is waiting for the for loop syntax. So we can put the semicolon back, and now if you run, this will run very perfectly without any error. Now let me show you how to write a for loop that looks like a while loop that you can find in other languages. So let me clear this out. And now what we can do, or I can just comment this whole thing. I can take it down and I can say while loop. And in here what we can do, sum colon equal to, will say 1. And below this, I'll just call for loop. And I'll not give init statement and post statement. I'll just give the condition expression, and we don't need to give semicolons. And this will still work because Go compiler will know that this type of syntax is present, and it will run it accordingly. And we can just go ahead and print this. And you can say it is printing 128 because sum starts from 1 and it will go till 99, and it will add all those numbers in between them. So this is how you can write a kind of while loop in the form of for loop, because Go only has only for loop inside the language specification. Now let me show you how to make an infinite loop. So for that, what you need to do is just remove the condition expression, and now it becomes a for loop. And just before that, I will just comment this out so that afterwards you can just get it very easily. Just copy this and paste it here. So now if you go ahead and see this, I'll remove the condition expression, and what we can do, we'll paste this inside here and can say infinite loop. And if you go ahead and run this, you can say it is printing 1 again and again repetitively. So this is an infinite loop, and what we can do, Control C, and it will come out of this loop. Now how you can come out of this infinite loop? So what you can do is add a break statement with a condition, and when it becomes true, then the loop will break and the control will come out of this loop. So let's go ahead and do that. Let me just copy this, make it comment, and let's say break statement in infinite loop. And in here, what we can do, we'll have our sum plus equal to sum, for example, and we are just printing the sum. And if at particular value, if you want to come out, so we can use if sum equals to 8, let's suppose, then we'll say break. And now if you go ahead and run this, let's clear this out and run it again. It will print 2, 4 and 8. So when the value becomes 8, it will come out of this loop. So this is how you can use the break statement. So now I will show you one more statement called continue. So this helps you to skip iteration after particular condition. So whatever comes after this continue statement, that is skipped. So let me copy this quickly, comment this out, and this will be continue statement in infinite loop. And what we can say, we'll have if statement here, if sum equals to 8, we'll say continue. And we'll print a sum here, and we'll say when sum becomes 32, it will break out of this loop. So let me show you. So here you can see that we have, when sum becomes 8, it will just continue the statement and it will not run the print statement. So when the value is 8, it is not printing the 8 value here, and it is just going again, it goes forward to print 16 and 32 but not 8. Hello and welcome to another video on Golang tutorial for beginners. So in today's video we'll be looking at how to use for loop along with a range clause. So before we get started, I'll show you this GitHub page. So this is my Go programming repository in which I am uploading all the codes which I am showing in the videos. So here you can see I have given like switch statement, in which I had shown you how to use switch statements in Golang. So all this code is available here. What you need to do is just go outside here and you can just fork this and you can star this. So when you fork it, and you can give your repository name here or your profile name here, it will come here. This repository will be copied on your GitHub profile, and from there you can just download it like this and you can work with that. So here you can see all the different codes I have uploaded. So in today's video I'll show you how to use for loop with range clause. So we'll start with the slices. This variant of for loop allows to iterate through arrays, pointer to array, slice, strings, maps or values received on a channel. So let's start with the slices. So I will show you the basic use case. So we'll make one slice called numbers colon equal to, let's say, open close square brackets, then I will give string because we'll be making a slice of string. In here we'll give 3 values, for example 1 in a string format, then we'll have 2, then we'll have 3. Okay, now what we'll do, we'll create one for loop, and it will take, for example, this is a index, so we'll give idx comma num, and colon equal to, we'll give the range. So after the range clause, we'll take nums. So this is a slice we are working on, and open close curly braces. So what this will do, it will take the index as well as the value from this numbers slice or nums slice. So here we can just go ahead and print fmt.printf the values we are receiving from the index and the numbers. So idx is the index, so it will be %d, then we'll put a colon, and then we'll put a %s for the string that is coming from the nums slice, and it will be in the form of num, and we can just go ahead and put comma, and we'll put idx comma num. And if you just go ahead and run this, let me clear this out, and we'll take this down. And you can see it is printing 1, and then the second index, that is of first index is 0, second index is 1, third index is 2, and the values associated with this index 1, 2, 3. You can just go ahead and format it properly, and if you go ahead and run this, it will format it correctly, and it will print 1, 2, 3 with index 0, 1, 2. You can do one more thing. I'll just copy this and paste it down here, and instead of getting the index and num, I'll just get the index and I'll just print the index here. That is also is possible. And if you go ahead, and before that I'll also show, you can also print only num, and you can say what we need to do here is we'll put a write operator, then comma. So this will work. Now you can see, first we got the 0, 1, 2, 3 as the key value pair, then we got 0, 1, 2, these are the index which we printed here from here, and the last one is the values, that is 1, 2, 3. So this is the values which are present in the slices. So this is how you can work with the slices in range clause. Let me comment this out. Now we'll go ahead and show you the next thing, that is arrays. So arrays has a similar syntax. What we can do, I'll just copy this, and we'll just uncomment. So in here what we can do, instead inside this square bracket we'll put 3 dots, so that will create this as a array. And now let be all the same, and if you go ahead and run this, it will print the values. And one more thing I will show you here is we can keep the for conditions empty, and we can just put for range nums, and we can just put whatever you want here. So for example, I want to put Gunesh, or I want to print Gunesh here. So if you can do that, if you go ahead and run this, you got the usual values on top, then you got Gunesh, Gunesh, Gunesh 3 times printed. So that is due to the this version of for loop where we only have range without any condition expressions. And you might be asking why we need to put the colon equal to here. If we remove this colon equal to, it will say that these underscore and num should be put, otherwise those will not be initialized. So we'll put colon equal to, and that error will go on. If you do it like equal to, and we'll put and now the next thing I'll show you is how to work with a pointer to array. with the for range clause. So that will be almost identical to the arrays, like pure arrays. What we need to do here, I'll just copy whatever I had done earlier. In here, if you see, before the array we have to put ampersand. So this becomes a pointer now, pointer array. And when we are calling that array, we have to put a star here. That is a dereference operator, and it will get the values from this pointer array. So whenever you are working with the pointers, remember that you have to give ampersand to get the location for the array. And whenever we want to get the values, we have to give the star operator or the dereference operator, and rest will be same. And I will show you one more way in which we'll have both of these. One will be with the star and with nums. So it's saying num declared and not used. That is because we have not put num here. And if you put it right now, I'll just remove this one because we don't need it. And we'll have these two different for loops, and we'll remove this one because we don't need this. And if you go ahead and run this, uh, we have to put %s also, and you can see it is printing index 0, 1, 2 with 1, 2, 3 values, and again it is printing 0, 1, 2 and 1, 2, 3. So both of these are valid syntaxes, in which one we can use star and another in which we can use nums. So both of them are same, and you can use that. Now the third thing I will show you is how to use it with maps. So when working with maps, we can do the same things. So only thing is that we'll remove this and we'll put map here, and we'll have map which will have string as a key value, and value will be integer. So it will be a key value pair. The keys will be in the string format and values will be in the int format. So what we need to do, after 1, it is in string format, we'll put 1. After 2, we'll put colon, and then we'll put 2, and after this 3, we'll put 3. So this will suffice, and we'll put this as m, and we'll comment the earlier code. Now you can see our errors are gone, and instead of this I'll just write it again. So we'll use for range and m, and we can just put in here, we can just put for k colon equal to range m. From the m we are getting the keys, so keys are 1, 2 and 3 in the string format. So for that, what we'll need to do is we'll just copy this to save time for ourselves. fmt.printf, in here we can just go ahead and put keys, you can just put print %s, or we can use %q. So difference between both of them is %s will just print the value, but %q will make double quoted will print double quoted strings. So I'll show you that, and we'll just remove this idx and num with k, and if you go ahead and run this, it will print keys 1, 2 and 3. And if you remove this %q and put %s, you can see it is printing without double quotes. So that's the difference between the %q and %s. And what if you want to print the values too? So we'll just copy that and we'll just paste it here, and we'll have k comma v, and you can say key is %q, and then comma value %d. I will have k and k comma v, So this will work. If you go ahead and run this, you can see key is 3, value 3, key is 1, value 1, and key is 2, value 2. As I already told you in the maps video that keys are unordered, so it can get anywhere. So you can see it is printing 3, 1, 2. So these are not ordered like arrays and slices. And the last thing I want to show is short variable declaration and scoping. So for example, if we had same thing, just copy this and paste it here, and this will just modify it according to your needs. I will remove this and we'll make a string here. And if we had 0 also in the string format, and we remove okay, so we had a slice of strings which had 0, 1, 2 in a string format, and we'll make one value, for example where idx integer. So this is our index, and we have explicitly given it as a with a where keyword. And what we'll do here, we'll just use idx in the for loop, range m, and the earlier code will just comment so that we'll not get errors here. And in here you can just go ahead and remove this line. So this loop will iterate over the indexes present in the slice. So we'll just print after that the index. So what we are doing here is that we are getting the index and we are printing it outside the for loop just to check if we get the index or not. And one more thing is we can't redeclare it because it is already declared above. So we'll just make it as equal. And if you go ahead and run this, it will print 2 because the index goes from 0, 1, 2 and the value is 2 when the for loop is exited. So we are getting the value here because it was explicitly given outside the for loop. So what if we do this inside? So let me just comment this, and in here what we'll do, this index, instead of creating here, we'll initialize it here, index colon equal to, and when you go ahead it will give an error saying that undefined index. So outside this for loop, this index can't be read, so that's why we are getting error. So whenever you are working like this, remember that, give it on top and explicitly declare it so that you will not get error, or the value which you want after the for loop also, then you can use this one. So this is how you can work with the range clause in the for loops. So I'll see you in the next video. Hello and welcome to another video in Golang tutorial for beginners, and in today's video we'll be looking at defer keyword in Golang. So let's get started. So what is a deferred keyword? A defer statement is used to ensure that a function call is performed later in a program's execution, usually for purposes of cleanup. And a defer statement pushes a function call onto a list, and the list of saved calls is executed after the surrounding function returns. And a defer statement defers the execution of a function until the surrounding function returns. So this I have taken from the Golang documentation. So let me explain you this. So let me open the Visual Studio Code. So in here I have one statement, that is printf statement, which is printing hello. So what I will do, I will add one more statement, and which will print my name, suppose Gunesh. So if you go ahead and run this, it will print hello and then Gunesh in a sequential order. So what if you go ahead and add deferred keyword in front of the first statement? So if you go ahead and run this, it will print Gunesh first and then it will print hello. So what it has done here it has deferred the first statement, which means it didn't print the output of this first statement. It just immediately executed it and moved to next statement. And when the function, that is this main function call, is returned, which means when the control comes out of this curly braces, at that time it will just print whatever was deferred. So when the function was returning, at that time it just checked if any deferred statement or functions are there. If they are there, then it will just print that. So like that it has done. So in the same way, what if we had like more than one deferred keywords? So let me just copy this and I'll add one more statement here, and it will print my surname. So, and what I will do is I'll add defer to all the three statements, and let's find out what happens now. So now you can see it is printing in reverse order. So all the deferred statements are put in a stack, and stack is a representation of LIFO, that is last in first out. So Shanbhag was added last, so it came out first, then it was Gunesh, then it was hello. So in the LIFO order it has printed all the different items it was having in the stack. So this is how a defer keyword actually works, and it's very convenient way to execute a piece of code, and it is mainly used for the cleanup purposes. So I'll show you one more code in which we'll open a file and we'll add some values, or we'll add some text inside that file, and when we close it, we will just use deferred statement or defer keyword to close the file properly. So now I will show you the second example in which we'll be using it, the defer keyword, for cleanup purposes. So defer is used to ensure that a function call is performed later in a program's execution, and usually for the purposes of cleanup, to be honest. And defer is often used where example ensure and finally would be used in other languages like Java, etc. So in this example, what we are doing is we are creating a file, then writing to it, and then closing that file when we are done. And here's how we can do it with the defer keyword. First of all, I'm importing the OS library in the import function block, and we have created three functions. So this code I have taken from the website called gobyexample.com, and I will give you the link of the website post in the video description also. So in here we are creating three files. We are defining that create file is there, in which we are just getting the path to the file which you want to create, and we'll return one file object pointer. So we have not seen how to work with the functions. In the later videos I will show you, but I'm just giving you a general idea. So what this function will do. So we'll first print the creating as the output, since we are inside the create file function. Then we are using the create function from the OS library to just create one file, and we are passing the p, that is the string of the file name, to the create function, and we'll just take the f, or you can say file object, and we'll save it and we'll return it back to the main function. And if there are any errors, if the path is wrong or file name is wrong, we'll just print it out using panic, and I'll show you the what is the use case of panic statement or panic keyword in next videos. The second function is write file. So whenever you are inside this write file, and first thing is that it will take file object, file pointer object as the input, and it will just print writing, and then it will just print the string data inside the file. So we are taking the fprintf, fprintln function, and inside that we are passing the file object as the first parameter, and second as the data which you want to print or data which you want to include in that file. The third function is close file, and the close file will take the file object pointer again as parameter, and it will just print closing on the screen, and while closing it will just check if there are any errors. So for that we have created a variable called ERR, and inside that we'll just pass whatever the output we are getting from f.close or the file object close function. And if there are any errors, if error is not equal to nil, means that there is an error, we'll just print out that error using fprintf and parameters, that is standard error output and the error and what is the value of the error. And we'll just exit the program using the os.exit function. So I have not given the function calls, so I'll just create the three function calls for the three functions. So the first one would be, we'll have one file object, so we'll have f colon equal to, we'll call the create file function, and inside this function we'll just pass the path to the file which you want to create. So I want to create in the temp folder, that is temporary folder, so I'll give /temp, then /, then again data, or you can say defer.txt. So this will send the path of the create file, and it will just return the file object pointer from the create file. The next would be, usually we can give write file, and it will have f, because we have to pass the file object pointer. And the third function would be close file. It will also take f as a file pointer to close the file. So generally this will work, but we can use defer for this purposes, so that we don't need to worry about any errors we are getting in between. So what I will do, before writing the file, we just defer the close file. So the execution of the close file will only work or only execute when the main function has executed all the other functions such as write file, etc. And when the control will be coming out of this main function block, or the main function will be returning, at that time the defer function call will be returned, and we'll get any errors if there are. So this is one handy approach when we are working with the opening and closing of files. Or now if you go ahead and run this, we'll see that first it is printing creating, that means it has gone inside the create file function, then it has gone into write file function for writing, and when the main function returns the call, at that time the deferred function call, that is close file, will be run, and it will just print closing. So this is how you can use defer statement. And one more thing is, I'll just check if the data which we added to the defer.txt is printed or not. So you can see data as a string is inside the present inside the defer.txt. So this is how you can use defers keyword while working with the file operation, etc. There are many other approaches also. So this for the beginning, and you can go through this approach. So thank you for watching. I will see you in the next video. Hello and welcome to another video in Golang tutorial for beginners, and in today's video we'll be looking at panic keyword in Golang. So what is panic keyword does? In some cases, when a particular abnormal condition occurs in a program, at that time we need to prematurely terminate this program. So in this case we'll use a panic keyword. The automatic way of handling the abnormal condition is in a Go program is using errors. Errors are sufficient in some conditions, but some conditions where the abnormal things happen, at that time we can use panic. So let's go ahead and open our Visual Studio Code, and I'll show you the examples. In the last video I have shown you how to do file operation, and we had used deferred keyword for the close file function. So in this example, if you go ahead and just remove the path for which path to the create file function which you are giving, that is the path to the defer.txt file. So if we pass an empty path as a string, let's see what happens. So you can see it just prints creating, that is it has entered the create file function, and then it just panics because it got an empty directory or empty path. So you can see the error open and no such file or directory, and you can see the stack trace here. So it is first go routine 1, that is the program this program is running, and in this, in the main, from the main function we have passed the control to the create file function in which the panic has happened, and then the main function has, the control has gone back to the main function, and we got the exit status 2. So here you can see that it has panicked in here in the create file function. It just prints creating, and the path which we had given, the p, it was empty. So while os.create function was creating the file, it found that the path is empty, and it just sent the error to the error keyword or the error variable. So when it found out that error was not equal to nil, means there was an error, we panicked and we just used the inbuilt panic function to show the error. So this error variable we have given here. So that's what we got. And as soon as it panicked, the control went from this function, the create function, to the main function, and it just terminated the program without executing the line 18 and 19, those who are having close file and write file function. So this you have to keep in mind. And one more thing is, if we have used any deferred statements or deferred function in your program, so for example, if I make this print statement as deferred, what will happen is, when the program will go into panic phase, when it create file function will return to the main function, at that time it will just execute all the deferred function. So before stopping the program or before terminating the program, it will just print the creating because it was a deferred statement. So it looks for a deferred statements, that's what I had already told you in the slides, and then it will just close the program. Now let's go ahead and look at another example. I'll just zoom out a little bit. So this program actually uses one function. The function name is account details. So what we are doing here is, we are taking a user ID, and you can see in the main function, and we are taking the branch code. So this is about the bank. So, and we have a account details function. Inside this function we are passing both these parameters, user ID and branch code, using ampersand symbol. That means we are passing it by using a reference, that is a pointer. And when the account details function will get these arguments as pointers, we'll just go ahead and print the values of that, and we'll just print the return normally from account detail function. So let's just go ahead and run this. So in here you can see that we got 4, 5, 6, 7 and 12. So this is the output we have printed in the account details function, and then we got the return normally from the account detail function, and returned normally from main function. Now let's go ahead and just comment this branch code, and instead of passing a branch code, we'll just pass nil. And let's go ahead and run this. So you can see that we didn't use panic keyword in this program, but still we got a panic because panic is a built-in function, and then runtime error has occurred. And while passing the arguments, you pass a nil argument instead of passing a memory reference. So it got a nil pointer reference, and you can see that it has gone to the main account details, and then it got back to main function. So let's go ahead and add some panic keyword logic. So for example, let's just check. We'll just add error handling here. So we have user ID first. So user ID equal to nil, let's say. Then what we can do is we'll just panic auto message. So inside here we'll just panic that we got a runtime error, and user ID can't be nil. So same way you can say for the branch code also. So we'll add branch code, and we'll just say branch code can't be nil. Okay, and if you go ahead and run this, you can see that we got a panic error, but now we are not getting the inbuilt error since we are putting a custom error here, that is branch code can't be nil. So this is how you can customize the panic keyword and you can get a different output. Now let's see what happens when we add defer statements in this program. So I had added some defer statements here. So in the function main we have a defer statement, so it will say deferred call in main function, and in account details we'll have, in the beginning we'll have a deferred call in account details. So currently what is happening here is without the deferred call we are just passing first it will say return normally from account detail function, then it will say return normally from the main function. Now let's go ahead and run this with the deferred statements. So you can see that first it is printing deferred call in account details, then it is saying deferred call in main function, and then it is just panicking. So that means it has put this deferred call in main function, this statement, in stack, then it went into account details function. So when in account details function it got encountered this again deferred statement, it has put in the stack, and when it encountered a panic, at that time it stopped executing the program and it was going to take the control back to the main function from the account details function, but it checked for the deferred statement. So it found that it has one deferred statement, it executed that and it just printed out. So first this deferred statement was printed, then it came to the main function, the control came to the main function, and then at that time it just checked if any deferred statements were there from earlier. So it found this deferred statement and it is printed that, and it didn't execute any of the code from the line 26 and line 17 and 18. So this is how deferred statement work along with the panic. So this you have to keep in mind. One more thing I forgot to tell you yesterday in the deferred keyword video. For example, let me comment out the other code. In the main function in earlier code, if we have exactly one variable which is a string variable which contains name and it's my name, then we have a print statement and it is printing the name, and we are making it as deferred, and then again we are printing the value and we are just changing the value of the name variable. So if you go ahead and run this, you can see that it is printing Gunesh and it is not printing the value which we added later. So why this is happening is because the defer statement takes the value from the first statement it has run. So while running in the beginning it was having this value as Gunesh. So when we change the value from Gunesh to lol, it didn't take it to consideration and it only took the value from the earlier one. So that's all guys. Thank you for watching. I will see you in the next video. Hello and welcome to another video in Golang tutorial for beginners. And my name is Gunesh Shanbhag, and in today's video we'll be looking at recover keyword, which will be used to recover a program from panic. So in the last video I had shown you an example where we had used defer along with the panic. And so now what I will do is I'll just copy this program that we have written earlier, which was about account details with branch code and user ID. I will just copy it in a new file. This will be a recover file. So in this we can see that we have one function, and so I will show you how to recover from panic. And recover is a built-in function that is used to regain control of a panicking program. So our program is panicking while branch code is nil, so we'll take care of that. And we have to keep in mind that recover is only useful when we call it inside a deferred function. So we'll need a deferred function here so that we can get back the, or we can recover the program from the panic. So what I will do is, first I will create a function here on top. We'll say recover account. This will be our function, recover from the panic. And what we'll do here is, we'll just create a variable with r. The name will be r colon equal to, we'll call our function, that is recover function. And after that we want to add one more line, so we'll just add a semicolon, and we'll check if r is not equal to nil. So if r is nil, then we don't need to worry about anything because it's not panicking. And if suppose r is nil, not nil, that means there is some panicking happening. And what we'll do here, we'll just print out the cause of the panic. It should be, and inside here we'll say recovered from, and then comma r, and we'll add a new line here. And now we need to call this recover account function to recover our account details. So wherever the panic is happening, inside this we'll remove this defer statement, which is printing deferred call in account details. And instead of here, we'll just call that method by using the deferred keyword, defer recover account. So keep in mind, whenever you are recovering, you should use a defer keyword to call that function, otherwise it will not work. And rest will be same. And if I go ahead and run this, you can see that it is first printing recovered from, then it will print the runtime error, which is in the panic function, and then it will say return normally from main function. Then it will call any deferred functions or deferred calls in the main function. So let me show you the execution stack trace. And one more thing is that we can't see the stack trace here, and we'll take care of that a little bit afterwards. And I will show you the how the flow actually works. So when it starts from the main function, it will defer the first call, and this will be put on stack, and then it will go to account details function. It will call this function, and then inside here it will defer the recover account function. So this is also put on stack, and then it will go in the branch code equal to nil, and will get nil. So it will panic. So as soon as it panics, it will stop the execution of the program. It will try to come out of this account details function. So before coming out, it should run this deferred function. So it will run this recover account. So the control will go to recover account function, and in here you can see that it will try to recover, and it will just print out the recovered from and the error it was getting. So the panic error will be printed here, and then after that it will come back to the main function. So because this is the top level function, it will come back here, and in here it will execute the next statement because it has been recovered. So it will just execute the normal execution of the program. So it will print recovered normally from main function. Then it will just check, before exiting the main function, it will just check if any deferred functions are there or deferred statements are there, and it will just print deferred call in main function. That is what is happening here. It will just recover from runtime error, branch code not equal to nil, branch code can't be nil. Then it just check return. Then it will just print return normally from main function. Then it will just say deferred call in main function. Now I will show you one more example. So we'll just, before that I will show you how to get the stack trace, because we can't see our stack trace like earlier programs. So what we can do here is we have to import one more library. That library name is we are like importing from the inbuilt library runtime. From that we will like to import debug. If you go down and inside the recover account function after the println, what we'll do, we'll just call debug.print stack. So print stack function is called, and if you go ahead and run this, you will get a concise view of the stack trace. So you can see here recovered from, it will got a runtime error, and then it will show the stack trace as it has gone from 24th line to 16th line, the recover account function, then it has gone to account details function again when it encountered a panic, and then back in the main function. It has printed the remaining statements. So this is how you can get back the stack trace if you're not getting. And I'll show you one more example here. So I'll just comment out everything and I will just copy and paste the example. So what is happening here is we have one slice named n, and this should be without three dots, which means it's a slice now. Before it was array, and the slice has three elements, 5, 7 and 4. And in the next line we are just trying to access the fourth element, which is not present. And we'll just go ahead and run this, and you can see that we got a panic saying index out of range, that is 4 with the length of 3. Now what we can do is we'll add recover function here to recover from this program, or recover from this panic. So we'll say func recover slice panic, and we have if r colon equal to recover, then we'll add semicolon, r is not equal to nil, which means there is an error. In that case we'll just print out the error saying recovered from comma r, and in here where the panic is happening, we'll add that along with the defer keyword, which means that when the panic happens at that time, this recover function will be called. So you have to remember that recovering or recover functions are always prefixed with the defer keyword. Now we have called this, we'll just go ahead and run this. So you can see that it is first going in the recovered from runtime error. So when the panic is happening, it is recovering, and next line is it has returned from the main. So you can see that when the panic was happening, it was not printing this line, because as soon as the panic was happening, it was just coming out of this slice panic function, and it was also coming out of this main function. But in this case, it has recovered from the panic and it has printed the last line of the main function after the panic is happened. So this is how you recover from the panic. So thank you guys. I'll see you in the next video. Hello and welcome to another video in Golang tutorial for beginners. My name is Gunesh Shanbhag. In today's video, we'll be looking at functions in Golang. So before starting, first we'll look at what is a function. So function is a block of code that performs a specific task. And a function will take an input, perform some calculation, and then it will generate an output. Let me go ahead and create a function and show you how to do it. So in here, we have a function that is a function main. So what we'll do, we'll create one more function. So if you want to calculate an amount of sales, what we can do, we can create a function for that. In function name we have to give, so we'll give function amount, and inside this we have to give the parameters. So the two parameters I want to give is price, and the data type of this parameter would be integer, so we'll give int. Then the next parameter would be quantity, so qty and then int. And after this we have to give the return type of this function. So the return type of this function would be integer, so we'll give int and open and close curly braces. So inside here we have to write the function body. Before that we'll go ahead in the function main. From here the call will go to the calculate amount function. So in here I will create two variables, one is price and other would be quantity. So we'll say price comma quantity colon equal to, we have to give the values, so we'll give 20 comma 5. And then what we'll do, we'll create one more variable, total amount. We will initialize it, so it will be colon equal to, and we can just call the function. So this is the function call, and inside this function call, that is calculate amount, we have to give the parameters. So we have two parameters, price comma quantity. So we are passing these two variables, price and quantity, to the calculate amount function. And once they are passed to the calculate amount function, the control will go to the calculate amount function. And in here we are accepting this price and quantity, and what we'll do is we'll just create a new variable where total amount to calculate the amount, and we'll just multiply both of these, and after that we'll just return the value of total amount. So keep in mind that the return type is integer, that is what I have given here, and once it is returned the control will go back to the main function, and in here we'll just print out the value of the total amount. So we'll say total amount colon, then %d because it's an integer value, then we will say total amount. So if you go ahead and run this, it will say total amount is 100. And we have to make this as printf. And now if you go ahead and run this, it will print total amount as 100. One more thing here is, if you go on top, in the parameters list, in the calculate amount function, we have given two separate parameters like price integer comma quantity integer. When the parameter type is same, what we can do here is we'll just remove this integer and we can say price comma quantity integer. So this is valid since both the parameters or all the parameters passed in the function are of same data type. So if you go ahead and run this, it will just output the same value. And what if you want to return more than one value? So for that I will show you one more example. So let me comment this out. I will just say it's example 1. Let me pull it down, and in here we just create func main, and we'll create one more function here. So for example, if you want to calculate the area of equilateral triangle along with the perimeter, so for that what we can do, we can create a function, say equi triangle, and inside this function we'll have two values. For calculating the area of equilateral triangle, you will need two things. One is the base and another one is the height of the triangle. So we'll take base, this is the parameter 1, and we have to write the data type of this, so it will be float 64 comma the height, that will be also a float 64 value. And in here we'll just calculate the area and the parameter. So before that we'll just go in the function main and we'll just declare the two values or initialize the two values, base and height, colon equal to, let's say 10.5 comma 4.6, and in here we'll just create two values, two variables, area and the perimeter, colon equal to, we'll call the equilateral function equitriangle function, and inside here we'll just give, or we'll just pass the base and height as the two parameters. And now in the function equitriangle, what we can do is we'll calculate the area and the parameter. So where area equals to, the formula is half into base into height, so we'll just write 0.5 into base into height, and the parameter we can write it as 3 times the base would be the perimeter of the equilateral triangle. And now we'll return both of this value, and while returning, what we have to do is we have to give return type in the function declaration or function definition. So this will be the first line. So whenever we have to give more than one return values or multiple values, we have to give it as into parameters. So we'll write float 64 for both of the return values, and we'll just go ahead and print them in the main function. In here we will say area is %f slash n, perimeter is %f slash n, and we'll just print area comma perimeter. So if you go ahead and run this, let me clear the console. It will say area is 24.15 and perimeter is 31.5. So that is correct, as you can see. And here also we can do, we'll remove the float 64 from base because the both of the values have same data type and this is valid. And one more thing here is we can just use name returned values. So in the name return values, what will happen is we don't need to give these values here as return area and perimeter. We can just remove them and we can just pass only the return. We can just put return keyword, but in order to make this work, what we have to do is we have to name them in the first line of the function. So where the return values are given, we have to do area float 64 and the perimeter, and now this is valid, and you can see that it is saying area redeclare in this block. So what we can do is we can just remove the where keyword from both of the values, and now this is valid. And one more thing is you can just remove the float 64 from the first area variable. And now if you go ahead and run this, it works the same way. So this is for named return types. Okay, and I have shown you in the earlier videos we had used blank identifier, that is underscore, to discard any values. So if you are getting two values here, such as area and a perimeter, we can discard the perimeter and only we can print the area. So we can do that. Only thing is that we have to give underscore here. If you go ahead and run this, you can see it is only printing area is 24.15. So that's all guys for this video, and I will see you in the next video. Hello and welcome to Golang tutorial for beginners. My name is Gunesh Shanbhag, and in today's video I'll be showing you how to use first class functions in Golang. So what are first class functions? So according to the Mozilla web documentation, a programming language is said to have a first class functions when functions in that language are treated like any other variable. For example, in such a language, a function can be passed as an argument to other functions and can be returned by another function and can be assigned as a value to a variable. So these are the three features of first class functions. The first one is a function can be passed as an argument to other functions. Second one is it can be written by another function. And the third one is function can be assigned as a value to a variable. So let's start with a simple example where we can assign a function to a variable. So I will create one variable called first colon equal to, will not give a function name because this is an anonymous function, which means this function will not have a name. So we'll just call func keyword, then open close parenthesis, then curly braces, and then we can just print out whatever we want to print, or we can give the function body, and here you can print inside the anonymous function. Okay, and now how we can call this function is we just have to use this variable first, and we can just use open close parenthesis just to call this function. If you want to print the type of this function, you can just use fmt.printf. Inside here we can just use inverted commas. Inside that we can just put %t, which means it will just print the type of this function, and we can pass first here. So this is the variable. So we'll just go ahead and clear this console and we'll run our program again. And now you can see that it is printing inside the function, anonymous function, and it is printing the type of the function, that is func. So this is how you can assign a function to a variable. Now next example I will show you is you can just pass arguments to this anonymous function. So let me show you how to do that. So what we'll do here is instead of calling this variable separately, we'll just remove this variable, and now we'll just remove this variable also, and now our program will be func. And since we didn't call this function, we will just use open close parenthesis after this curly braces. So what this will do, this will execute this function, anonymous function, without you needing to give the variable. So we go ahead and run this. It will still print inside the anonymous function because it doesn't need a variable to assign to. And you can just pass any variable or any value here. So I'll just want to pass a string, and we have to give that here also. So we'll just say str string, and if you go ahead and run this, it will print inside the anonymous function, and we didn't include that string in here, so we'll type it out fast. So if you go ahead and run this, it will print inside the anonymous function and hello there. So this is how you can pass strings to anonymous function. One more thing is that there are different user defined data function types. Like I have already shown you in structures that we can create our user defined structs. In the same way we can create user defined function types. So let me show you. So let me comment this out. So let me create a user defined function type. So we have to use the keyword type, then we have to give the function data type you want to use. So we'll name our user defined function type as add, and now you have to give the signature of this function. So what this function will do, so this function will take 2 input and it will return 1 output. So we'll type func, so this is a keyword, and inside this we'll give a int comma b int, which means it will take 2 input, that is 2 integers as input, and it will return 1 integer as output. Now let's see how to use this user defined function type add in our code. So what we'll do is we'll create a variable or var, and the name of that var would be a, and we'll say it will be having a function type of add, which will be equal to, we have to give the function we want to create. So we'll just say a comma b int, and this will return the integer. And in here you can see you can just return a plus b, and we can create a variable called yes, for example, colon equal to, it will be of type, we'll call the freshly created a here. So we'll call this variable a, and inside this we'll pass the values which you want to add. So for example, you want to add 50,5, and then we can just go ahead and print this. We'll just print sum comma yes. If you go ahead and run this, let me clear the console, it prints sum as 55. So let me show you what happens here. So we are creating a variable a of type add, and the function signature matches with the function signature of the function type we created earlier. So whenever we pass the input as 50,5 as 2 input integers to this a, it will go inside this function and it will return a plus b, and that we are saving in the variable s, and we are just printing it out. So this is how you can create a user defined function type. Now let me show you how you can create higher order functions. A higher order function is a function which takes one or more functions as arguments. Another thing is it returns a function as result. So let me show you how you can pass a function as argument to other functions. So we'll just comment this out quickly, and in here what we'll do is we'll just comment this also. We'll create a variable f colon equal to, it will be an anonymous function, so we'll just create func. Inside the parenthesis we'll give a comma b int, and then it will return integer. Now inside the function body, what we'll do is we'll just return a plus b like the way we did earlier, and what we want to do is we'll call a function simple, and we'll pass that variable f to this function. So we have to write the simple functions definition here. So we'll create a func simple. Inside this we'll pass the function. So we have to give a variable name for this function. So we'll give a as the variable name. Then we have to give the func, that is the signature of this function. So a comma b int, and it will return the integer. So whatever you are passing as f, it should match. So this should match with whatever we are passing inside this function. And we have given a variable a because it's an anonymous function. And while we are using inside this simple function, we can use a to get the values. Inside the, we'll call the a function, and inside that we'll pass 50 comma 5. So if you go ahead and run this, it will print 55. So what happens here is we are creating an anonymous function which will add two variables a and b, and we are passing that to we are assigning this function to a variable f, and we are passing this variable f to a function called simple. Inside this function we are matching the function signature with that of the anonymous function f, and we are creating a variable a to use this function. So we'll call this function a, and inside that we'll pass the two variables 50 and 5. So now let me show you how we can return functions from this simple function. So before that I'll just copy this, and because we wanna comment this out, I'll copy this and I'll paste it here. Okay, so what we want to do is we'll take this, since we are returning functions from other function, we'll copy this function, it is anonymous function, or we'll cut this out and we'll paste it this inside this simple function. Okay, so the function anonymous function f is inside the simple function, and what we're going to do is we'll just return this anonymous function from this simple function. And let me remove this. Okay, and now in the main function what we have to do is we have to create a variable. So we'll create s colon equal to, and we'll call the simple function here. Okay, and now we'll just use that s variable to pass 50 and 5 to this simple function. So whenever the simple function will get those values in the form of the anonymous function, it will execute and it will return the anonymous function. And accordingly we have to change the signature of this simple function. So this function signature simple will have, earlier we had the input as a anonymous function, now we are returning function as output. So we'll just remove this and we'll make this function as the return type. So we'll remove a also. So all this is a function, anonymous function, which we are passing to the main function, and there are no arguments to the simple function. It just gives out, returns the anonymous function. So this is how you return functions from other function. So let me go ahead and run this quickly, and now you can see it is printing 55 again, the same way as earlier. So we have seen anonymous function in this video. Along with that we have seen user defined function type. Then we saw how to pass functions to other function. Then we saw how to return functions from other function. So that's all guys. Thank you for watching. I will see you in the next video. Hello and welcome to Golang tutorial for beginners. My name is Gunesh Shanbhag, and in today's video I'll be showing you how to work with interfaces in Golang. So let's get started. So what are interfaces? So an interface is a set of method signatures. That means an interface will contain methods. So when a type provides definition for all the methods in the interface, it is said to implement the interface. So there will be many types which will provide definitions for the methods which are included in the interface. So when it does that, we can say that it implements that particular interface. For example, if I take an example of washing machine, so washing machine can be an interface with method signatures cleaning and drying. So these are the two methods which will be present in the washing machine interface. So any type which provides definition for cleaning and drying methods is said to implement the washing machine interface. So I will show you in the code how to create an interface and then how to use methods and the types to implement the interface. So in our code, what we will do is we'll create an interface first. So let's say interface definition. So this will be our comment. Let me zoom in. Okay. And now what we'll do, let me zoom out a little bit. Okay. So we'll create one interface. So the syntax is first we have to type the keyword type, and then we have to give the name of the interface. So in our case we'll give it as generic. So it's a generic interface, so I have given the name as generic, and then we have to write the keyword interface, so all in small letters, and after that just open and close curly braces. So inside this you have to give the methods or the method signatures which you want to implement afterwards. So let's say we want to implement an area. So this area can be of any geometrical shape like circle, pentagon, rectangle, square. We are just giving it generically here. So the return type of this function would be float64. So now our interface is ready. So now let's create some types to take the input for these different geometrical shapes. So to create a type, we have to use type keyword. Then we have to give the name of the type. For example, I want to create a type of circle as a geometrical shape, and this will be of type struct. And then inside here we have to give the different parameters this type will get. So the circle will have radius, so we'll give radius, and its data type is float64. Then we'll create one more in type, so that type would be type rectangle, and this will be of type struct also. So this will take input as struct, and this will have width comma height, and both of them will have the same data type, so we'll give float64. In the earlier video I had shown you why we are using width comma height float64. So since the data type of both of these variables is same, we are giving it like this. Now let's go ahead and write the methods from the interfaces which are added to the receiver type. So let me just comment out for better understanding. So as a methods from the interfaces will be implemented and which will be added to the receiver type. So these two are the receiver types. So what we'll do, we'll create a function here, and this function will take the receiver type. So in our case we have circle and rectangle, so first we'll implement the circle. So we'll take variable c, then we'll say circle. So this is the object of circle type, and this will implement the particular function. So we have to give the function signature same as the particular we have given in the interface. So we'll write area open close parenthesis, then the return type is float 64. So this is our methods on the interfaces are implemented for this particular interface. So unlike Java, where we use implements keyword and we use classes to implement particular interface, we don't need to use implements keyword in Golang, because in Go, whatever you have to do, it does automatically and implicitly. So Go compiler will take care of all the implementing of the interfaces. You just have to give this particular syntax, and Go compiler will take care of all the things. So what we'll do, we'll return the area. So we'll use return keyword, then we'll calculate the area of the circle. So we'll use 3.14, that is the pi value. So pi r square. So we'll just use, instead of using the math package, I'm just using the c dot radius twice to calculate the area. So I'm getting hold of the radius and radius data field from this particular type by using the types object c. So that's why we have c dot radius here. Otherwise we'll not get hold of these particular circles variables. So similarly we'll add for rectangle. So I'll just copy paste it here, and this will have r, say rectangle, and what it will return is width and width into height. So we'll use r dot height into r dot width. So we are returning the area of the rectangle also here. Now what we'll do, we'll just calculate the area. So for calculating the area, we'll just create one function, calculate, and this will take an interface. So we'll create one interface variable here. So we'll name the variable as g, then we'll name the variable, the interface variable. So it will be generic, because generic is our interface name. Then open close parenthesis, open close curly braces. Then inside here, we'll just print the values which are getting from the interface. So we'll just print fmt.println. We'll first print the g, and then next we'll print the area. So we'll calculate the area using the g variable, g dot, we'll say area, and we'll call this function. So this function is part of this interface. You can see here area. So whenever we call g dot area, it will go here and it will find out that this particular interface, that is a generic interface, is implemented here for both of the different types. So we have circles implementation here and rectangles implementation here. So accordingly it will choose the particular receiver type, and it will calculate the area and it will show, or it will print the area here. So now what we'll do, we'll just create main function. So inside main function, what we'll create is, we'll create two variables, one for the type rectangle, another one for the type circle. So r colon equal to, we'll call our type to give the values or pass the values to it, and rectangle is type, it takes struct as input. So we'll just pass width colon, we'll say 3 comma height colon 4. So these two values will pass to the rectangle struct, rectangle type, and for circle we'll use c colon equal to circle So inside here we pass the radius colon 5. So we have passed values to both of the types. Now what we'll create, we'll call the calculate function to calculate the area. So we'll call calculate, and inside here we'll pass the variable r and c. So let's pass c also. So what happens here is when you call calculate function and pass r here, so this r object is passed to the calculate function implementation or definition here, and it is equated by the interface variable, which is equal to, let's say if we had g here, it should be equal to g equals to r, otherwise g equal to c. It's the same thing, but what we are doing is we are just directly passing that r and c values, object values, inside this interfaces g variable, and accordingly g will call the area function and it will implement accordingly. So let's just go ahead and run this. Since we are passing first rectangle, that is r, it should calculate rectangle's area. So you can see 4 3s are 12, so it is printing the area correctly. Then for the circle we are passing the radius as 5, so 5 square is 25, 25 into 3.14 is 78.5. so this is how it is calculating the area using interfaces. So the practical usage of interfaces is, suppose we want to add some more geometrical shapes. For example, we want to add pentagon or square or hexagon. So there are many different geometrical shapes. So if you want to add these geometrical shapes, then you only need to add the types for this particular geometrical shapes and only the definitions here, and no need to change any code because interfaces will take care of all the things. So this saves a lot of time for us since we are not creating different area functions again and again. So this is a practical usage of interfaces. So I'll upload this code to GitHub so that you can use it. So I'll just show you. If I say GST, so you can see that the interfaces still need to be added. So what I will do, we'll add git add interfaces. So I've added a directory, and now we'll say git commit -m. We'll say interfaces in Go and hit enter. So a code is added or code is committed. So now we'll just push it to the main branch. So this is our link. So github.com gshanbag525 goprogramming.kit. My net is down, so I'll just upload it once I get back on my network. So thank you for watching, and I will see you in the next video.
Hello and welcome to another video in Golang tutorial for beginners, and in today's video I'll be showing you how to create a simple HTTP server in Golang. So my name is Gunesh Shanbhag, so let's get started. Okay, so here we are in VS Code. So first of all we'll import the package, we'll give the package name first, so it's package main, and then we'll import some packages. We'll use parentheses to import more than one package. So we'll import first fmt. We don't need a comma here. Second package we'll need is, since we are working with the networking capabilities of Golang, we'll import net package, and from that we have one more sub package of net, that is HTTP. So net forward slash HTTP. So we'll use HTTP package for dealing with the different functions which it provides for the web server capabilities. So let's go ahead and create a func main. So this is our main function, the starting point of our Golang program. So inside here, what we'll do is we'll call one function from HTTP package. So HTTP provides many different functions because it's an API. So we'll call HTTP, then dot, and here you can type handle. So here you can see handle func is there. So this function will allow us to give routes. For example, we want to give a route, suppose forward slash. So forward slash means a root directory. For example, if you go on google.com, so google.com's root directory will be this forward slash. So we are working with the local host, so ours will be local host, then a port name, then the forward slash. So if we go to this route, what will happen? So we have to give here second parameter as the function which we want to call. So function we want to call is let's say simple server. You don't need to give parentheses here because we are not calling the function here, we are just giving it the function name, and it will automatically call that function when the handle func is called. Okay, let's go ahead and create this function. So we'll type func simple server, and what this will do, this will take two parameters. So if you know the client server model, in that we have one request and one response. So whenever a client sends a request to the server will acknowledge it and it will send a response. So here there are two parameters in the simple server, or any method for your example. So the first one is the response. So we'll give a variable here called w. Then we have to get the response from the HTTP package. So HTTP dot, we have our response writer function writer. Here you can see response writer interface. So this is the interface which is provided by the HTTP handler to construct an HTTP response. So this makes our work easy. So then the next parameter is the request. So we'll say R, that's a variable we'll use for the request interface, and its type of pointer. So we'll give star here, then we'll give HTTP to call that package. From that we'll call the request. Here you can see request represents an HTTP request received by a server or to be sent by a client. So it's a struct basically. The first parameter was interface, that is response writer, and the second parameter was struct, that is pointed by the pointer. So we have to give something here, so we'll just go ahead and print the route of this particular URL. So we'll use fmt here, fmt dot, suppose fprintf we'll use, and in fprintf we have to give first our response. So our response variable is w, comma, we'll give any string here, so we'll suppose say hello, and it will be %s because we'll just print whatever route we have. Then to get that particular route, what we have to do is we have to take the R variable, that is the request variable. From that we'll remove the URL. For example, if we have google.com/docs, so we want to remove docs, so that's the substring of that particular URL. So we'll just get URL, then we'll get the path, that's a string, and it's a array actually. So we'll get the first one. So if one colon will give us will fetch the route of that particular URL, and that's all. And now when the handle func will be called, it will call the simple server function, and that will be pointing to the root directory. The next thing we want to create is we have to create the server. So we'll call the HTTP package again, then we'll call listen and serve. So you can see that listen and serve listens on the TCP network address, and it will call internally the serve, which is a handler, to request to handle request on incoming connections. So it does everything implicitly. So if you listen and serve here, so keep in mind that listen and serve will block the particular TCP connection. So as soon as you go, as soon as you run this program, you can go on the particular URL and you will get that particular response there. So inside here, we have to give first parameter as the port which we will be using. So we'll use port 8080 because that's the default port used by many systems. And second parameter, it takes into consideration an error. So we are just giving nil here. If you go ahead and run this, go run simple server.go, you're not getting an output here. It will give us a dialog box here that do we want the application simple server to accept incoming network connections. Just click on allow. Now you have to go into the Chrome browser window, and in here we'll go to localhost colon 8080. So if you go ahead here, you can see that it is printing hello. The one more trick here is it is not printing the one thing you can notice here, that it is not printing the r.url.path because we have not given any path here apart from the root directory, that is the forward slash. So let's go ahead and give a path. So in here we have to give localhost colon 8080, then forward slash. We can give anything. For example, I want to give my name as a route. If you press enter, you can see that it is printing it hello Gunesh here. So same way you can just remove it and you can print programming knowledge, and it will print hello programming knowledge. So this is how it works. It parses the root URL path, and then whatever is there, it will just print it out here in front of hello. And if you want to stop this, what you can do, this you can see that this command is still running. So hit Control C, and it will the process will be interrupted. And if you go ahead and again run this or refresh the page, you can see that that site can't be reached because the server is stopped now. So this is how you create a simple HTTP server. In the future videos, I will show you how to use different handler, etc., and also how to work with the HTTP GET request, POST request. So thank you guys for watching this video, and I will see you in the next video.